Check, 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 check.
ABB is changing too. Will the industry's leading portfolio of robots and controllers disappear? Or is the best going to get even better, faster?
Today is a whole new game, making smaller lots of tail.
I'm Cooper Lane, Vice President, Modular Construction.
check, 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 check. Check, 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 check. That's one. Check, check. Check, check. Check, check, check. 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 Yeah, that's actually. Check. 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 Check.
as we're walking.
Check, check. Check, check, check. Check, check, check. Check. Check, check. Check, check. Check. Check, check.
I can do a check, check here. Check, check. Okay, and how do I can't get it to, do I put extend desktop? Oh, it's on. Why do I have the backup?
It always happens just before the event. It just decided.
Seriously?
No, it doesn't want me to. No, it doesn't let me.
What? I just logged in though.
No, it doesn't. Sir.
What's extend?
Don't you want mirror?
Oh, yeah, but now it's up there.
Yeah. So do you want me?
What does that mean?
Like same on both?
Yes.
Yeah.
Okay. So I want to go back.
I think it just got confused.
Okay, that's good. Now I can plug this in. I will. No problem, Steve. Steve, you don't know Steve. Johan's there. That was my bad not having caffeine at lunch. Okay. Thanks, everyone. Thanks everyone for joining. It's almost unheard of that an event in the School of Architecture start on time, so even though we were ready at 12:45, I felt compelled to wait 5 minutes. So first of all, welcome everyone to this symposium on the future of construction. We're going to be exploring today how robotics and digital fabrication in architecture and concepts of design for manufacturing and assembly are poised to transform the construction ecosystem. So as architects, you know, we make drawings as a set of directions for building. It's very important how we make buildings, and sometimes we just kind of follow pathways that we've done, you know, for 150 years. So why are we doing that? You certainly don't draw in the same way that you did. You may incorporate that into your set of tools, but today we're going to talk about how tools are actually changing and how architects can be engaged. And I'm super pleased to have this panel here, which I'll introduce to you shortly. Basically today we're going to be exploring the themes of collaboration, which is really, really important. This idea of the architect of the solo, you know, at the drafting table all by herself is just, I mean, this has to be a myth dispelled. Pedagogy, so how we teach you these things and how you teach us, and we collaborate to do that together. And process. Process is something we talk about in architecture. We have a review, you hang things up on the wall, and we say, you know, we're not just talking about the final product, we're talking about the process. And so these things, this symposium is going to bring together leaders in industry who are here together today, with leaders in research from across the globe, quite frankly, and education to talk about their experiences and observations on how the worlds of design and construction are transforming and how we as architects are a critical part of that ecosystem and change. First of all, I'm happy to extend a warm welcome to the Philippe Fleischmann, who is here, has been with us for the summer on a sabbatical from ETH in Zurich, Switzerland, the DFAB lab. And so maybe Philippe, you can put up his hand. Yeah, this is Philippe. Hi. I'll introduce all the speakers. Also, ABB Robotics, Steve Powney is here. Thanks very much, Steve. This is Steve. Those beautiful robots you just saw dancing are just some of the smallest robots in his repertoire. So I'm really proud to have Steve here and hear what he has to say. From Porsche Consulting, online is Josh Miller. So I'm waving to him. He's in the camera. Those are the old days of the online worlds. I'm so pleased that the pit is full and to have you all here. From Intelligent City, who I'm sure you have all heard of before, O.D. Craig. And from Brave Control Solutions, and you'll understand what an integrator is after this talk, we have Cooper Lane and Greg Sullivan. So also students from our Sea Salt Lab are here and will be doing talking and doing a demonstration. Adonis Lau and Catalin Bacalou are here, yeah. The robot gurus now. And finally, I am joined by my colleagues, Professor Stephen Fye up front here, and Johan Voordouw, who you know as professors at the school, who will moderate and help ask some questions. But I hope questions come from the floor as well. So I love this little gift. It was from Russell Loveridge at the ETH, from the DFAB lab actually, who works with Philippe. Now the image is back there. It's a chisel on one end. It's a really heavy-duty chisel, and on the other end, it's a pen for kind of working your computer. And this kind of hybridity is something super interesting for me. You know, robots aren't going to be the answer to every one of our problems, but they are another tool. And in combination with, you know, our own kind of manual contributions and the human, it's really interesting. And so, if you don't know me, I'm Cheryl Boyle. I'm the director of the Sea Salt Lab. And we supervise research and exploration in innovative fabrication processes, in construction systems, in materiality, and really the lab is about collaborations. I call it a collaborative rather than a kind of, it's a big hierarchical thing. The students take control, they take projects and lead them. We have research projects and as many faculty as I can get involved. It's in the basement, we make a mess, but now we're actually up on the landing. Thank goodness the elevator isn't working because now the robots get to stay up here for a little while longer. So anyway, yeah, that's Sea Salt. Here's the program for the day. We'll have a couple of hours of talks, and then we want to make this a conversation. We want to involve you. So again, the order of the people that I've just described, this is the order they'll speak, and we'll finish up at about 4:15. Okay, so Steve and ABB, and so there's a little bit of a background I'll let you read, but the things that I love are where people, the background. So, you know, Steve told us a story about working for Jaguar and how, like, they were first integrating robots to make cars. And you think of it now, you think of a robot, it's like, yes, I need a robot to, of course, do something, but where everyone knows it happens is in the automotive industry. And so what other industries might it touch? And so Steve has been there from the beginning and is a kind of is a networker extraordinaire. Josh, who's online, you think, okay, Porsche, yes, I understand what a car is, but again, how can the processes, so if we look at process as one of those critical moments in architectural design, how can process, when we're designing something else, actually influence how we change things? So it's like, oh, we think about different things, we think about things from other points of view. And so Josh is going to bring some of that as a consulting firm and to think about how we make, fabricate buildings offsite. O.D. Craig is here. Okay, Intelligent City. It's like if we know if we think of mass timber and we think of like who's using robots to make buildings, Intelligent City is kind of leading the way, and so we're super glad to have you here. But what I'm really glad is O.D.'s going to talk about some of the things that as an architecture student that you think are rather speculative and you think how can this possibly, you know, what are going to be the connections to me as a professional later on, and some of the importance of those connections. And so I'm really proud that he's going to talk about that. And finally, Greg and Cooper, again, come from Windsor, Ontario, so homegrown talent, if I could say, or a homegrown firm, and we're looking at kind of integrators. So if you think of every tool, so all of you will be heading out, or you know, many of you have had before, you know, the shop introduction. It's like, I need to be able to work in the shop. Okay, what do I need to know about the end product and the process in between? And so when we start working with robots, robots are at one end of the spectrum, and if we sent any of you up there to the landing to say, okay, do your drawing for the Murray and Murray Prize on these robots. I know maybe 3 people in the room that could do this. Maybe not including my guests. So somewhere in the way, along the way, there's what you want to do and what the tool you have to do it. But then there's people that bring those things together, that build bridges for us. And so many of the people that will speak today are bridge builders. And so Cooper and Greg are just those 2. Finally, Johan, whose students are here from the first year of our program. Welcome to you all, and this is kind of an exciting and interesting lecture. And so Johan's interests in digital design practice, architectural representation and fabrication. Johan is the other professor in the school who has the most sawdust on him. So if you can't find him anywhere, you can always find him in the shop making something. So one of my favorites. And a longtime friend and colleague, Steve Fye, runs the lab at Sims, and he and Nico are here, also Christine Prucknow, who is the person who runs the big robots at the back of the school, the orange ones. Christine is here, and sitting up there. And so Sims is this kind of powerhouse of a laboratory at Carleton, and if you don't know about it, you need to. It's a wonderful way to think about relationships between, you know, the world, digital acquisition, BIM, and where we go from there. So there's my promo pitch for Sims, Steve. They're hiring. Okay, so what happened? This summer, we were very, very fortunate to strike up a wonderful collaboration with ABB, thanks to Steve Powney, who's here. And so, and also a second collaboration that was equally important for us here at the school with the National Center of Competence in Research and Digital Fabrication, so the DFAB lab. And so the most important thing if we have a new tool is to think about, first of all, what is that tool? Is it the appropriate tool? And then what are we doing with it? And how will we use it? And so those things came together with a group of students, and I always like to highlight the students, and they're in red from various different backgrounds, various different levels of education, and we got up and running. And so Adonis and Catalin at that time were just finishing 4th year in architecture, and so their software skills were coming up, and I say they, I'll let them talk about it, but they really embraced this idea of what the robots could do and how to speak that language. And so we have much to thank to Philippe for that. And Philippe has been our mentor, shepherd, guide, almost kickboxing mentor for some people anyway, and also has another bridge that he'll speak about that's called Compass RRC. That is really designed for the architecture field. And so I just want to, I'm going to point out 3 concepts and then stop talking. Really, architecture is about design and specifications. Design is what we're used to. We make images of buildings, of spaces, of public space. We think about mapping. We build models. We build prototypes, mock-ups. Specifications are the other part of architecture that pretty much you only end up doing when you're in a firm. They're text-based descriptions. They're instructions for execution. They're how to put up a tile, how to do something. And so if we think about this detailed reference to materials and materiality, actions and patterns, and instructions, then really instructions are really, they can be parameters. So the parametrics of design, and they can be code. So how does that change things? It changes things. It only changes things if we change the tools. Tools inform design, but, I mean, and you could say, you know, it's like, oh, yes, that's a Revit building. Like, I understand how that tool informed that design. But design also informs tools, and so can designers. And so 3 projects that happened at Sea Salt. One was a 4th year studio project that turned into a full-scale design project. And it really taught me about pedagogy, and it brings this idea of pedagogy to the forefront, ways of teaching. And that particular project was intimately tied to the CNC machine. So that tool informed that design, but the design also informed how we went about this, because we thought, well, it was a very, Ben Hayward's project. It was something that we needed to work on curvature in 3 dimensions. The project then became what we were doing at small scale for a piece of furniture, and we scaled that up. We worked with Arup on the structure for this thing, and this kind of crazy giant waffle grid house, which could be very heavily insulated, which Ben was interested in doing, became in the final product on the right-hand side of the screen. And so the CNC machine intimately affected how that project came around, and it was on HGTV. So anyway, it was a huge undertaking. It ended up being his master's. You can't finish a whole tiny house in 4 months, for sure. Process. Process is the second theme, ways of making. And so we thought about how do the tools that we have inform the ways we make. And in this case, the tool I'll talk about is the Scara V4 3D printer that a student was working with over COVID in the lab down in the basement with ultra high performance concrete. So a concrete that has fibers within it that ideally means you can use less concrete. And if there's a material we want to use less of, it's concrete. And so with concrete research, we're always interested in ways to use less. And this moves on to our next project as well. So these were a series of experiments and failures, most important failures, that led us to understanding the relationships between the material, the tool, and ways of making. And we understood then that the 3D printer on that Scara robotic arm, the most important thing is the tool path. So the path that the tool takes, like a cake decorator, it kind of moves. And that movement is the thing that we needed to draw. So his drawings, in effect, were actually lines in 3-dimensional space, which was the movement of the nozzle of the 3D printer. And so in the end, Sinan's project, and this is Sinan Husek, a thesis student, was a chair, a very small scale project because that was the scale that we could kind of make with our 3D printer. He built it in 2 halves and put them together, and that thing is so strong. While we didn't take it over to the structures lab and break it, we stood up and down on it as a team, and there's no breaking that concrete chair. It's very heavy. We could make it half the thickness we know in the end. Last theme, collaboration. Ways of working. Collaborative ways of working are incredible. If I could say that the design of the School of Architecture, 20 years ago, if you came here, there were individual work tables with individual parallel rules on them, and everybody worked individually. There was the hub, you know, this little gallery thing with a fireplace, that used to be where people kind of came together to discuss. Today, we have much more collaborative spaces. You can actually, you know, sit around a table, talk with your classmates. Really, really important. So if you take that into the idea, the studio, into the idea of a future, what a workplace, but also an ecosystem, who are the people you're collaborating with and what are those ways of working? And so the tool that we were referring to in this project is the same Scara 3D printer. It was the only robot we had at the time. And and we were shooting for this competition that is held by at the University of Waterloo. And so David Correa ran this exhibition with Isabella Coa, and they invited us to participate in an exhibition called Robotic Clay. Collaboration. And so immediately, last year was my first year back after a sabbatical, and so I built a team, and Seasalt there's 8 of those 10 students. We were all working on research projects. 8 of those 10 students were working on this competition. We spent times getting to know the tools, safety, all of those things, but we also started to get to know the materials. And so the material we were working with was clay, something new to us. We worked with an industrial clay, but we also worked with wild clay. And then we brought that together with a series of softwares. So we were working with the idea that this would be a prototype for a concrete wall. So we wanted to use as little material as possible. Process was very important, and collaboration within the team was equally important. And so we started off just drawing on the chalkboard, and although this is a reconstruction, our drawings were much better. This is our student Megan that put together all of our sketches back on the chalkboard in room 208. We also worked with the other tools, so the computational tools. We were working with Rhino, Grasshopper, and Topos as our topology optimization software, finding ways for this wall to use as little material as possible. So we started off with this idea that we would take an old style wall, like a double wide brick wall that most buildings in the UK would be built with, where the structure is on the outside and then there's fill and rubble and ties in the center. And we said, let's put the structure in the center. And use as little material as possible and let the bricks be a veil, a kind of a ghost of that wall. And so just if you think that you can then do the digital model and then hit print, just think again, because this is us using our 3D printer. Of course, you know, the angles we were printing things at needed a little reinforcement, and so it was more like of a campfire around the robot, where all of the students collaborated and made this thing happen. We built the structure up. We realized that this very beautiful materiality of clay came out in the way that the stepper motor in the 3D printer extruded the clay. You have this like little roping that happens on the lines of the 3D printed clay. And then the mortar itself was a project to work with some of the UHPC stuff that Sinan had done in the past, building up a kind of a new method of digital fabrication using the robot. And so the project went up. An all-nighter happened, and then there it was, and it's on exhibit now at the Canadian Clay and Glass Gallery as part of the robotic clay exhibit. So code, if we could say the specifications for that project, then became our drawings. They're just the floor mat, you walk on them, they're not too precious. But so the code and the tool path for the project were the things that kind of came out of that. So where do we go from here? There's always thinking about new pedagogies, new processes, and new collaborations. And so in the big scope of things, our project aims to work with existing buildings always. I teach recycling architecture. I'm really interested in the existing buildings. We have a great conservation sustainability program here. But also to think about a research environment and that basically expands the current limits of accessibility. How can our new tools, so how can our robots actually expand the kinds of people and that are actually in the construction industry, adaptability and automation. So in the end, we want to expand and enable a diverse trade sector to complement how we do construction today, or hopefully completely transform it. Last point, our new tools, collaborative robots. And you see here, they arrived and we called them Thelma and Louise because robots always have male names. Robots are like male genders often. But anyway, so we had Thelma and Louise because they had a good car. And so we are incorporating these ideas about robotics code into a number of different courses. Johan is here. Nico is here, also from Sims, that'll be incorporating coding and advanced coding into a course on representation. And we have a new course on digital design and fabrication with robotics with our two robots here. And so coming up this year at Carleton. And so to launch these kind of ideas, first of all, I want to thank our speakers and now hand the mic over to them. And we'll begin this journey with all of you. So the first speaker will be a duo of Philippe and Adonis. So, yeah, thanks.
Hi, so my name's Adonis, and I'll start off a bit by telling you a bit about myself and why I'm up here talking to you here today. So I graduated my Bachelor of Architectural Studies here at Carleton just this past April, and I'm starting my MArch here, the 2-year master's program. But last year, in my 4th year, I joined Sea Salt with Cheryl, and that was when I started to get some digital fabrication experience and exposure. But before that, I came from a pretty, I think, traditional, standard architectural student background with mostly just design, dealing with digital software, everything digital model, physical hand modeling, but nothing with robotics, coding, programming, or digital fabrication in general. So this picture on the left here is a photo of the team last year. And I joined Sea Salt last year as a research assistant and team lead. And through the projects that we had last year, my role sort of developed into leading the research into digital fabrication and also software, and looking at how these emerging technologies can play a role in design, and specifically in architectural design. And this project here that Cheryl mentioned was the main project that we did last year. And I just want to point out my role in this project was, my main role, I worked with another student, Megan, who we generated the design using Rhino and Grasshopper. So there's a software side of it. And for those of you who don't know, quickly, Rhino is just a 3D modeling software that a lot of architecture students and architects are familiar with. And Grasshopper is an extension to Rhino that lets you essentially code geometry. So instead of manually drawing a box, you put in parameters for the box, and it updates, but I'll talk a bit more about that later. And the other part was dealing with the printing process. So once we had this digital model, turning this information into G-code, which is essentially the instructions for a 3D printer to read, to run, to actually print, and then also managing the printing process. And now currently at Sea Salt, this summer we just got the new robots. I'm continuing my journey with digital fabrication. And in partnership with ABB Robotics, we're looking at how robotics plays a role in construction, and also how robotics plays a role in architectural education. So that's essentially using the robots as a teaching aid to teach architecture students how to think with robots and also how to design with robots. So there's more of a connection between your design and how it actually gets built. And as Cheryl mentioned, this summer we started working with Philippe over here from NCCR DFAB at ETH Zurich in Switzerland, and I'll pass it over to him to give an intro about himself.
Hi, everyone. It's a pleasure for me to be here. And before I start, I would really like to say thank you to Cheryl that she hosted me here during my time here in Canada. I was able to do a sabbatical here for 3 months together with the team from Cheryl. And it was, one of my intention was to push me out of the comfort zone, that I had to learn new stuff. And even to be here on stage today is a step out of my comfort zone. Another intention was I want to collaborate and share what I have developed in Switzerland. And so in the next few minutes, I will give you a little overview or a scope of what we are doing in Switzerland and what we have done here in the summer. So first of all, you have to understand in Switzerland, it's not comparable like here in North America. We have only 2 universities. And I work at the ETH Zurich. This is the biggest university in Switzerland, and that's my base. The ETH has 16 departments. Obviously, I work in the department architecture, but my background is I'm an automation engineer and a robotics technician. I never studied architecture, so there was another point of going out of my comfort zone, going into collaboration and make steps forward. So ETH has around 500 professors and 25,000 students, but we have also more than 200 apprenticeships. That's very important. So you see the whole variety of skills and disciplines and peoples, and a big goal from all of us is to collaborate together. So how does Switzerland collaborate better? One way is they have projects called National Competence Centers, and one of those is the NCCR Digital Fabrication. The NCCR Digital Fabrication is a project who runs over 12 years, and we have 3 phases. And in each phase, the government is spending more than 10 million to invest in collaboration and to bring different disciplines together. We work together with 25 professors. Maybe I switch to the next slide. This gives you a little bit an overview. I have to see this a little bit here on front. So where's the pointer? Good. So here we have, for example, Philip Locke. He is a really big professor for structures. And on the other hand, we have Fabio Gramazio and Matthias Kohler. They run together the the Gramazio Kohler research program. And Matthias and Fabio brought the first robot in architecture on a university in 2005. But then we work also with people together like Marco Hutter here on the top. He is the co-founder of the Animal, one of the walked robotic stocks. Good. What we're doing at the DFAB, we're focusing on 3 main challenges. This is on-site digital fabrication, it is bespoke prefabrication in our lab, and the third big part is really the collaboration. Coming to my background. So I joined with 16 years the workforce. I did not study on a university like you guys here. I just joined the workforce and started to learn all the basics of automation. So I wired up motors, valves, and integrated sensors in electric cabinets. After that, I pushed myself forward towards PLC programming. I spent it over 3 years in just programming machines, in making the codes of them. And then I could move on to industrial robotic cells. So in the end, I was a project leader to install robots on site, but I made also the program, and I was there with the client together until the machine worked for them well. And in 2016, I joined ETH, the university, and then I started to collaborate together with architects. So, and on this slide, here you see a few results of my work together with ETH and together with other architects. In the middle, you see the DFAB house. On the top, on the left, you see the roof from our lab. This is a wooden-made roof with over 50,000 members. And on the bottom, on the right, you see the latest project, the Semiramis project. And this was done with, we used AI tools for the design, but we used also our prefabrication lab in Switzerland, and we coordinated four hanging robots together to make all these pots. So behind these results, this was my playground. Here you see a little bit how my view is usual in my lab. So I have to work with all the PhDs together, and we have to find ways to make the processes happen, and we have to develop tools. And in 2016, when I started, we had not really tools to control the robots. And one of my outcome was to create a tool that students can more easily operate the robots. So, software toolkits. Today, I can present you Compass RRC. I'm one of the developers of this, but for sure I have also other teams, other members in my team. But before I dive in a little bit, or before you understand the concept of Compass RRC, I would explain the big packages. So Compass, ROS, and ABB, or industrial robots. First, it's the Compass framework. The Compass framework stays for computation, for architecture and structure. It's basically a huge toolkit of Python tools. So it's something for you in the future to use. Compass is much more than RRC. Compass has a lot of extension, and everybody can contribute to it because it's an open source project. So, for example, for digital fabrication tool, we have the slicer extension, we have RRC with the robot in the middle, and we have the fab tool to make the processes. But then we have also engineering extensions to make an FEA analysis or more. The other big package, I cannot explain all the package in the details because this will take too long, but just that you get a rough idea. There is this other big open source package, it's called ROS, and ROS stands for Robotic Operating System. But ROS is not an operating system. ROS is a great middleware and a great tool to bring software developers together on one base. So, for example, robots like this are developed on a base, on a fundament of ROS. So they are rich with libraries to integrate LiDAR sensors or other advanced sensors. And this makes the life for the developer way easier. And then the third part in this architecture is the industrial robots part. For sure, this is not comparable with let's say, the new robotics, with this research robots. But ABB robot, for example, has a rich history, and they have developed a lot of tools for everybody. And there is a difference between develop a robot or use a robot. And in my environment, most of the time, we use the robot. And so we want to take all these tools from ABB and all the others to operate with them to produce new processes. So back to the overview, Compass RRC combines the three pieces of software. So we bridge between industrial robots and the ROS environment, but we bridge also between the ROS environment to the Compass environment, and the Compass is the bridge to any design tool in the front. So the Compass core is all Python based, and it opens up a lot of freedom for you in the future. To have a simple start, we ignore the middleware ROS at the beginning. We pack them in a black box, we just start them that we can make the connection. And you guys, if you develop something with a robot, you can really just directly focus on the project code at the beginning, and on the back end, RRC is executing your information. So with this slide here, I want to show you a little bit how these crazy projects where you have seen before worked. So on the bottom here, that's usually the normal part where people's just go in contact. So GKR was the project lead of the project Semiramis, and they went to the client VZug and did all these exchanges. They had these chats together to find out what they want to do, and this information they produced or computed through the Compass core into a data container. So at the beginning it was with simple information like length and height of a plate, but in the end it got more and more data, and it became a treasure. To access this treasure, we use Rhino and Grasshopper for visualization, but also for controlling the process flow. And when we execute the process, then we push the data to Fab and to RRC to make the robot runs. So in the end, this is a little bit the structure of all those project works in the background. And yeah, now I come to a video to show you a little bit what we have done this summer together with the team of Sea Salt. A big thank you goes from my side also to Adonis and Katalin. They really both spent a lot of time to develop all these codes, and it was a fantastic time for me.
Those three projects. Test? Okay. So those three projects that you saw in the video just now, this slide here is just a very high-level brief overview of the process that it took to achieve the final result, starting from design. So in the design environment, in our case, we use Rhino and Grasshopper, which I'll go a bit more later in the next slide. This is, as I said, a 3D modeling software that allows for parametric design that a lot of architects and architecture students are familiar with. So in this design environment, we create the geometry, we create the design that we want, and in our case, it was a drawing, a tower, or a wall made of bricks. And from that, we export the information of the geometry into a data container. And in our case, it was a JSON file. And if you don't know what that is, it's essentially just a file format that we chose that stores any kind of information. But the reason that the data square is down there is because it is an optional step for us. We could directly send the design information right to the process management, but we just wanted to have a middle step just to keep track of everything. But the process management is where you start planning everything. So getting the information from the design environment, planning out the robot movements, writing out the code to say how you want the robot to move, where and when, and from that you export the information to the robot and to fabricate the design. But I wanted to point out here all of this, it's not just a one-way communication. It's not left to right. There's two-way communications at every step. So the process management, you send information to the robot, but the robot can send information back so you can read it and update things as you go. So this is just this little video is just a demonstration of how Grasshopper works. So on the left is just the inputs part of Grasshopper, and on the right is Rhino, which is just the visualization for it. So here you can see, instead of modeling manually a box and copying and pasting it over and over again, everything is driven by sliders and parameters. So it's a lot easier to iterate through designs and get through what you want. And in our case, it's just a simple wall with curves. So this is the front end of it. And in the back end, this is what Grasshopper looks like. So it's a visual programming language. So it's a lot more accessible to students like me who don't have much or didn't come from much coding or computer science background. It's a lot easier to pull blocks and connect them with wires than write out lines of Python code. So this next step, the data container, as I said, the JSON file where the information is stored from the design environment. So on the top left there, you can see what kind of information we store, and this is all up to us. Anything that you can output from Rhino, yeah, you can put in here. So we have the block dimensions, and then the frames info over there at the bottom is just where the location and space where we're telling the robot to place the block to make the wall. And process management. So this step is what Compass RSC achieves, and this is where you customize your code to and customize how the robot moves. You can make it do anything you want. This is up to your creativity. You just have to know how to code it. And on the left there, you can sort of see what the code looks like. It's relatively simple. Yeah. And this video here is just the output of what that Compass RSC code looks like on the robot. Cut it short there, so it's not a 2-minute long video. But so that was just an overview of what we've done at Sea Salt this summer. A lot of exciting things. A lot of new toys, which is fun. And if you want to know more, here are some links to Sea Salt. That's our website, and also to DFAB. And if you wanted more information on Compass, these are all the links to get there. Yeah, thanks.
All right, we're going to do a computer changeover. It worked pretty seamlessly last time. I'll set you up. So those were some small-scale experiments. Now we're going to introduce you to some very large-scale experiments. Actually, they're not experiments. It's true, they're real things.
They started that. They started that.
So I'm very happy to give the mic to Steve Powney here. So just play.
Is this the videos, right?
Yep, that's the number one.
So, okay, well, thank you everyone. Thank you, Cheryl, for inviting AB. Thank you everyone for attending, and thank you very much, Cheryl and her team for arranging this opportunity for ABB and for our partners in industry, Brave, Intelligent City, Porsche, and others to enable us to explain to you why ABB and why ABB have got a great interest in the construction industry. So we're going to start this off with some videos because a lot of talking's been involved. So we're going to show you 4 or 5 videos and then talk about where we stand within construction in robotics. So I'm going to stop talking now. I'm going to show you some videos. Hopefully they're interesting, but there's certainly things that we've had success in. There's certainly things that have taken the construction industry by storm, and with partners and colleagues in Canada. So Canada is leading or on the leading edge of this revolution in construction industry, and we should all be very proud to be part of this journey. Thank you.
Automation is changing, more and faster than it ever has before. ABB is changing too. Will the industry's leading portfolio of robots and controllers disappear? Or is the best going to get even better, faster, smarter, and more tailored? Over the coming years, our portfolio is going to see some sensational changes. Starting with robots and controllers made for a digital collaborative world, and built on a modular approach that will allow us to expand the industry's widest range of robots even further, with more robot types and more robot variants. We'll be able to bring you new innovations faster, and we'll be able to combine our portfolio in exciting new ways to offer you more tailored solutions, to meet today's greatest manufacturing challenges, and to be flexible for tomorrow's opportunities. Faster innovation, greater flexibility, more tailored solutions. Welcome to ABB Robotics.
So this is the first video of one of our partners from Brave. This is one of the starting applications and solutions that were at the start of the revolution, as we call them, to the construction industry here in Canada. So this is a very important position for us to consider.
I'm Cooper Lane, Vice President, Modular Construction with Brave Control Solutions.
And I'm Jason DeFazio, Director of Engineering.
We're a solutions provider located at the heart of North America's automation industry. And we're proud to be a valued provider partner with ABB Robotics. About 3 years ago, we were asked to build a weld cell for offsite construction. It sounded simple at first, but we quickly realized it wouldn't be easy to solve. Our customer was faced with a number of business challenges: a lack of skilled labor, a huge increase in demand for their product, and they needed to increase production outputs without sacrificing quality. The main challenge is that our customer needed to build products that have an almost unlimited number of variations. To accommodate their variable product designs, we created a machine where all of the components move independently to suit whatever product is being built.
We used 8 6650 robots for welding, and 8 8700 robots for installation of tooling, material handling, and all the robots were integrated into 7th and 8th axis custom rail systems. We develop custom weld packages and custom dressing packages designed specifically for our application, along with laser smart tack sensors and weld guide.
We streamlined our delivery processes and shortened our project timelines by using ABB's setup and configuration services. We trust ABB to help us surprise and delight our customers. It doesn't get any better than that.
ABB's absolute accuracy and multi-move were key tools for us, considering all of the movement we had to coordinate and the precision and quality that we had to exceed.
The service, the support, the solutions we get from ABB is incredible. Really, the best in the business.
Okay, so that first video you saw is metal. So we're talking, the first video you saw there is metal, so we're talking about steel. The next video you're going to see is from our other partner, Intelligent City. This is mass timber, wood. So these are two of the critical things within construction within our journey. And thank you, Oliver David, for being here.
I'm Oliver Lang. I'm the CEO and co-founder of Intelligent City. We're an urban housing technology company. We're basically providing end-to-end solutions for our customers. So a decade ago, we decided that in order to overcome housing affordability and supply issues, to address climate change and the systemic lack of innovation in our industry, that we needed to heavily invest in technology development, including manufacturing, automation, development of our timber-based building systems. And robotics was really a key ingredient for this new approach.
We partnered with ABB in order to learn from their expertise about different ways of automation and to add our own expertise in prefabrication, specifically for mass timber prefabrication and mass timber construction. On the one side, ABB is providing automation equipment, but on the other side, ABB is providing a lot of expertise and knowledge about general manufacturing processes that really help us evolve our manufacturing as well. What Intelligent City is doing together with ABB is that we are vertically integrating enough disciplines within one company so that a large portion of the traditional logistical chain of construction can be innovated at the same time. The automation equipment that we are using from ABB has allowed us to accelerate the manufacturing processes and in some ways simplify them, streamline them, but also really raise the level of quality of prefabrication. And it lends itself really to automating processes using industrial robots to allow not only a faster and more cost-effective way to produce building components, but a much more adaptable way to produce them as well.
Robots allow us to think about how we move away from this bespoke, one-off approach of buildings into something where we can provide qualities and performance standards across a whole variety of buildings and portfolios of projects by having a combination of really consistent processes on one end, quality control, advanced manufacturing, acceleration, paired together with the possibility to vary and adapt.
We are very excited about the potentials of the future collaboration between ABB and Intelligent City. We need a strong partner like ABB to come in with an extensive experience, but at the same time, Intelligent City needs to provide experience from the prefabrication industry, from the mass timber industry, and the construction industry. So this collaboration will be extremely fruitful, I think, because together we can evolve, together we can help make our industry more cost-effective and more sustainable in the future.
Okay, so that was mass timber. The next one is traditional stick type build. So we've got metal, we've got mass timber, and now the next one is more traditional build. Same sort of thing. And what you'll see or what you'll hear as we go through these videos is the key word, and it's collaboration. So the collaboration between ourselves and partners like you at Carlton, as you're being educated and moving to the workforce, is very key to enable this industry to move forward. And that's the key message we'd like to bring.
Autovol is an automated volumetric modular construction company focused on building multi-story, multi-family affordable housing across the western United States. ABB Robotics was introduced to us through House of Design Robotics, one of their providers, with an intricate knowledge of automation and technology. And so they've supplied the machinery and the technology for us to be able to do the things we're doing with automation and robotics.
So our partnership with ABB Robotics is formally called a value provider. So we use our engineering services to provide their robotics products to our customers. So if you're a manufacturer and you want to automate a solution, you can use an ABB robot, but you're going to need a House of Design Robotics company to provide all the value-added engineering services.
ABB Robotics has been a very integral part of Autovol. We've been able to come up with the machines and being able to have those machines do all the things that people would do in the normal construction world. We've been able to allow that heavy lifting and so forth that comes with construction to go onto machines and off of people, bringing younger people into our company and having people stay longer in the construction field.
A typical construction site would be doing the work on site. There's a lot of material loss on site. There's inefficiencies in the labor on site, timing, permitting, things like that. When you can do pre-built, prefabrication off-site, you can parallel path those and you can control your loss in labor, you can control the loss in the waste. And a robot is perfect for that opportunity. Automation is benefiting our construction customers in the typical ways: speed, productivity, throughput, helps solve their quality problems, but it's also helped their labor shortages as well. And it's allowed them to keep the labor that they have and provide them a better role or better responsibility into the manufacturing process. We've taken the mundane, the repeatable things that typically workers get tired of. It's a safety issue. We've removed those.
The cost of automation and robotics is an additional cost. But what we've proven here is that even with that additional cost, it saves us money. We get the repetition that we get out of a robot, we get the precision, we get the reduction in a workforce that doesn't need to be doing all the heavy lifting and straining that people do. And I know as Autovol, we are a prefabrication company that's prefabricating buildings and shipping them to the site. And so not only are we curbing their cost of the actual building, but we're also cutting their time up to 40%. We've seen it bring new people and younger people into our industry, which has been missing for a lot of years because of the technology and the excitement of it. We've been able to see the precision that does the same thing over and over again, so we can get that consistency in what we build, and we've been able to see the speed. And so it's those type of things that I think that every manufacturer will be able to benefit from.
Robotics is transforming the construction industry. There's a huge problem to solve: affordable living, affordable housing, the shortage in labor to provide that. It's not going to get solved unless robotics is part of that solution.
You're just going to
Yeah,
speak
the
now?
presentation, yeah.
Oh, which one?
The one I give you. The one I sent to you.
By email?
Yeah.
I only have the videos here, Steve. Oh,
It was on that stick.
all right. Yeah, we'll come back to it then. We'll jump back.
That's all right then. So
Yeah.
we'll come back.
Yeah.
So anyway, so that's three examples of success stories within our industry. So what we're going to do later, I've got a presentation to give as well. We're going to let our partners get their information out, and then we're going to explain to you at the end what ABB see the industry, the way forwards, what our plan is in the way forwards, and how we all fit into that plan. So when we've got the more information from our other partners, we'll try and bring together and explain to you the overall plan of how we're all going to move forwards into the industry as we go along. Okay, thank you.
Thanks very much, Steve. So we have a presentation then that's coming online from Porsche Consulting. So I'm just going to take, I might need Panchi to give me a hand. Just going to hide that screen for a minute. Just to make sure we've got just gonna, it's the online one. So I'm just gonna need you to enter it. Make sure it's gonna work here.
See myself.
Oh my gosh. So,
Just remind him to turn off his Bluetooth.
okay. There.
Just it's right there. Just click the
This?
wait on make it full screen.
Hi, Josh.
Oh, sorry.
Yeah, you need to share screen. We're just going to set you up to share your screen. And I'm going to need
Now connect that.
this. Can you make sure this works? All right, Josh, you're live here at Carleton University, so welcome to the pit, virtually. You have a couple hundred students here, and Josh is from Porsche Consulting, and so you're the first of the industry partners after ABB here to talk about automation and processes. So it's all yours.
Perfect. Thank you so much. And everyone, it's a pleasure to be with you virtually today to share a little bit of our perspective on kind of the intersection of industrialization as we've seen it transform automotive and how we see the potential to extend some of that to construction as well with partners like ABB, with Brave, and some of the other folks that'll be with us speaking today. So when we talk about automation and reimagination of construction, what we kind of point to is the industrialization of construction. And what I want to share with all of you today is a little bit of a perspective on why. Why is it interesting to take some of these perspectives? Why are we looking at so much from robotics, et cetera? How we can do it, and then really what it gets us at the end. And we'll answer along the way, why is there a sports car company talking about construction to all of you this morning? So to answer that question right up front, Porsche Consulting really helps other companies and other industries borrow proudly from some of the lessons learned within Porsche, within the automotive industry. And I think you heard some of those common themes from Steve. We'll hear some others from some of the other speakers today of where we can kind of borrow proudly from this. So Porsche Consulting is part of the sports car company. We do quite a bit of advisory work of really looking at how can we take concepts from production, supply chain, engineering, and apply those in other industries to help solve those problems. And if we look at construction, where can we start? There's a great quote from Einstein that many of you I'm sure have seen before of insanity is doing the same thing over and over and expecting different results. And if we look at how we've gone about the process of construction, it's largely been the same process over the last 100+ years as other industries have matured from adoption of technology, adoption of new processes, and integration across players in ways that we're just seeing emerge today within construction. So with this as a backdrop, if we look at the industry itself, why haven't we seen the improvement that we've seen in other industries? And we see a significant fragmentation across players in a huge market. If we look as an example in the US, north of $300 billion in the market, and the largest player from a construction management perspective is less than 3% of that total market. So you don't see some of the consolidation that drives some of the standards and the adoption of new technology and the integration of the value chain that we do see elsewhere. So we see still, a very traditional process of building buildings in the same way as design has evolved, style has evolved, and materials have evolved. But we still see an industry dominated by stick-built structures built by largely regional players without the adoption of new technology that we've seen elsewhere. And what does this mean from a statistics and numbers perspective? I think, as we all know, there's a bit of a shortage and a gap right now in terms of both some of the skilled labor and overall availability of residential housing is a specific example. We're seeing within construction demand greatly outpacing supply, and we haven't seen the response on the industry side to be able to drive some of the efficiency and unlock the productivity that we've seen in other industries. And just to quantify this for you, if we look at things like automotive or really other manufacturing intensive manufacturing intensive industries, we've seen automation drive significant increases in output. So this chart off to the right is really comparing construction with manufacturing and how we've seen just over the last 30 years, efficiencies get unlocked to drive 65+% more output per hour of human labor in all of these other adjacent industries that we haven't seen the benefit of that within construction. Largely based on, again, it being very much still the kind of traditional localized model and approach. So how can we reimagine this? How can we increase and gain the efficiencies that we've seen in other industries, bring that into construction, really reimagine how we think of building buildings and executing projects? And one of the big pivots that we see from Porsche is the shift from this project-oriented mentality that's been pervasive over the last 100 years to really shifting towards almost a product-driven approach of industrialized construction where we can standardize both design as well as some of the processes and specifications. So we'll tease those apart when we think of how can we look at standardizing process, how we can standardize different components of a product to be able to allow the creativity and meet end customer needs in the market while capturing some of the efficiencies and process that we can unlock leveraging proven methods and new technologies from the likes of ABB and others. So when we talk about this product-driven focus and how we can take that and apply that within construction, I think the first thing that pops to mind for a lot of people is kind of the post-World War II era of let's mass produce cookie cutter structures, and doesn't leave a lot of inspiration and it doesn't leave a lot for desire. If I pick on something that Cheryl opened up with, one of the first principles she shared around architecture largely consisting of design and then specifications, the process by which we, design, or the process by which we then, actually build a structure. This is where we can start to tease apart the nuance that allows us to really unlock kind of the next wave of offsite construction and modular construction that can still produce things a bit more inspirational than what we see on the screen. And I'll use an example. The 911 is a standardized product, 4 seats, engine in the back, goes down a single assembly line in Zuffenhausen in Germany. But in the same year, there's typically only 2 911s that are actually built to the same specification. And we can really see the same happening within industrialized construction with new processes and new approaches to be able to transform construction in the same way and still allow to differentiate from a product perspective, but gain efficiencies where it doesn't necessarily differentiate what we bring to our end customers, our end users, and our end residents. The way we see this goes through a couple different dimensions. We can foresee taking some of these proven technologies, high-end efficiency and automation in production, being able to bring quality products at volume and scale. And we see productivity not just from a how can we more quickly put things together, but looking across the full value chain. How can we better integrate design with technology, with process, and do that end to end and expand that with our partners as well? Borrowing from another automotive example, in a given car, about 60% of the value actually comes from our suppliers. So we need to integrate them tightly to be able to produce a product to our specifications that meets the market need and meets end customer need. And frankly, we see quite the same within construction as well, and have been working with partners to help ramp up multi-billion-dollar now managed supply chains to help drive efficiency for developers and for builders that are doing large-scale projects. And then lastly, and what this whole room and audience is really going to bring after graduation is, your knowledge of what the future will look like, and ensuring that as we build these systems to develop buildings in a more efficient way, that we future-proof them, not just to be able to bring, what delights customers today, but tomorrow as well, and ensure that we future-proof our facilities and future-proof our designs to be able to bring this to bear. So how can we do this, and how can we break it down? Well, borrowing proudly from adjacent industries, we typically see 5 core pillars to industrialization, and we'll get into more details of some of these today in some of the various talks as well. So if we look across the 5, product, process and organization, supply chain production, and digitalization, I'll go in depth on 3, but at a high level, from a product perspective, there's an opportunity, of course, to maintain the highly customized and mass configurability that we desire and want to be able to bring to projects, to individual buildings, yet standardize some of the things that may not be so differentiating. And we'll share some automotive examples of this. From a processes and organization perspective, there's significant opportunity to integrate across different functions that historically in the traditional building approach have been very siloed. So kind of gone are the days of handing a design document to then go through engineering to then be handed off to builders and skilled trades. What we're seeing is a significant transformation where organizations are starting to integrate across these processes, where we have architects, engineers, technologists, and builders in the same room developing product that will allow them to execute on projects in the future, managing mutual trade-offs across those disciplines to really optimize the end-to-end building process in a way that traditional construction methods haven't lent themselves to so well. And then lastly, of course, in production, and we'll get into some detail here, we've seen a significant maturity in automated systems, pragmatic automation, and a lot of Industry 4.0 concepts of data integration across supply chains be able to unlock new efficiency in adjacent industries that are starting to make their way into construction as well. And we'll go into a few of these just to give a couple pragmatic examples and where we can borrow from some of these adjacent industries and inspire the way we can operate in reimagined construction. So from a technology perspective, if again we look at the last kind of 30 years of where we've seen the 65% plus increase in output per labor hour across manufacturing industries, in Porsche we've actually seen almost a 400% increase in productivity per worker as measured in vehicle output per FTE that we have on staff in production. But in the same time, we've seen product complexity increase to where now we have window controllers that have more lines of code than an entire 911 did in the mid-90s. And what we've seen is really the application of what we call pragmatic automation, of looking at what are some of the things that we can standardize and really take some gains of efficiency through highly automating certain processes that can be standardized while still remaining, some of the differentiating factors, some of the custom interior elements, things like that, is still being hand-built to provide the kind of mass customization that people still want, from some of these products that are very personal, much like some of the buildings that people both live and work in every day. And if we look at what this means from a product perspective, there's an opportunity to look at how we can see modularized products in other industries like automotive, where we're able to come up with significant variation in products. Here, just an example, everything from four-door sedans, high-performance sports cars, and SUVs that are actually able to leverage some of the same both modular components as well as some standard processes to allow us to unlock the efficiencies that we seek to with kind of reimagined industrialized construction. A couple examples of this is seat frames. Across every vehicle in the lineup, we have the same seat frame, something that is necessary and required, of course, for the function of the product, but I don't think I've ever seen a customer get super excited and jazzed about the seat frame inside of their 911. Same kind of applies when we look in the construction world of what are those non-differentiating modules or components that we can automate, take off site, build more efficiently, and be able to differentiate really where it matters and be able to give us kind of the best of both worlds from a product perspective. And by doing this and by taking some of these modular approaches where we can standardize some core components, drive the efficiency that we want, and some of the automated lines like Steve shared, what we can end up doing is differentiating on the end product in that collaborative model where we can create new brands, differentiated spaces, and be able to tailor designs to different use cases and different desires using some of those core building blocks, but being able to do some of the mass customization that we can set up automated lines really to support and enable for us. This is an example here from Admares, a company that actually borrows from two industries that have gone through a good bit of industrialization, one within shipbuilding, and then the other, of course, increasingly in the last few years, looking towards automotive to drive the future of production. And the inspiration they took from shipbuilding, founder comes from that industry, is looking at the concept that while not every product will be standardized in the way that most ships have a significant amount of customization, the processes themselves can be standardized. So really the view and how they've approached this is how can we standardize some of the processes by which we'll build different, custom projects and custom programs, and be able to do that in a way that's very standardized, very efficient, and integrating across some of the silos that have existed historically within the industry. I'll give another example, just borrowing from the automotive world. Headlights are an area that we significantly differentiate from a design perspective. Each brand has its own identity. Porsche currently has the 4 lights in each housing that's noticeable from a mile away behind you on the freeway. These are things that are tailored to the brand and differentiated to custom fit every single vehicle. But the process to install them across any factory that these vehicles are built is it slides in on a track and there's a single cam to lock it in, and that's been standardized over the last 30 years. So any worker from any plant can perform that same operation. From a service perspective, it's been driven, it's consistent, and we can take some of these common process elements that then, of course, we can differentiate what we're building using some of these common modules and some of these common components scaled efficiently in some of these offsite production facilities. And when we look at the process transformation and how we can integrate and change the way that we execute, not just design, not just building, not just production, but if we look across the process as a whole of design through construction, there's significant opportunity that companies are increasingly taking down these silos and barriers where previously we'd have a standalone architecture firm working with a GC, working with different engineering disciplines to deliver an end-to-end program, increasingly seeing all these roles come to the table at the same time, like that example with Admares, where we have in the same room individuals from each discipline working together to be able to knock down some of the inefficiencies between these different handoff points and really optimize a program across those disciplines and be able to capture a larger part of the value chain and take out schedule, take out wasted cost, some of the points that Steve's videos captured, and be able to deliver unique programs quicker, more reliably, at better cost. So this is a bit the view of the how. And if we look at the what does this get us in the end? So there's certainly space for significant innovation and new concepts that we can bring to the industry and borrow proudly from what works elsewhere. And a couple customer examples that I think Cooper and the team will talk to in a little bit more detail coming up is companies like Boxable that have reimagined what modular construction and offsite production looks like, where they've been able to optimize designs for housing where you can effectively pack it up, ship it on a standard trailer, and have modules that can unfold and be installed on site, within, I'll say, unpacked within an hour and get installations done in pretty record time. Decreases our dependency on some of the skilled trades that are very limited, particularly right now out on the West Coast where they're serving quite a bit of build, and being able to produce these at greater and greater scale by automating the production lines to build the components for the casitas that they're producing. which Brave is supporting and has helped them unlock significant efficiency in both their current operations and looking towards scaling up significantly. If we look at really where to scale this even broader, is Admaris again is looking right now to build a 1 million square foot factory with a vision of being able to build houses like cars. And what they've done is they've looked at kind of mature production industries where we have automotive factories that have, as an example, supplier parks where we have sub-assemblies being built up by supplier partners within our facilities that are then feeding a main line. Having all of that in-house where they're able to really shift their reliance from skilled trades to be able to truly industrialize a production process that they can scale quickly and still maintain the flexibility in product design to be able to deliver very unique projects. So far, some of their marquee projects are significant builds in hospitality, where they've been able to do very, I'll say unique builds that certainly break from that earlier example that we shared. So in wrapping up, when we look at construction and we look at the opportunities in the market to take technology like you're seeing today and like you're working with and getting your hands on and borrowing proudly from other industries, we see opportunities to not only drive some of the business fundamentals of reducing cost, increasing supply and closing some of those gaps in the market that we see today, but being able to meet some of the demand that today goes unmet and unserved by traditional building and by some of the constraints we have in the market today. And hopefully what we'll share and have given some examples here, as well as to the rest of the day, is really be able to spark innovation and be able to enable kind of future design concepts, new technology, and be able to build for the future and be able to use these new technologies and new methods, not just to do what we do today more efficiently, but to be able to deliver the visions that all of you have as you're looking towards projects in the future in terms of how you can use new technology to still create something quite unique and work much closer with some of those other disciplines that allow us to do mass customization while still harnessing some of the efficiency of industrialized production. So I'll leave it there. Hopefully a quick snapshot at how we can borrow proudly from automotive and other industrialized manufacturing industries to be able to deliver differentiated projects within building. So thank you so much, Cheryl, and I'll hand it back to you.
Thanks, Josh. Thanks a lot. All right, we're going to leave you now, but I believe your video, your one-person YouTube channel is open to watch the rest of the presentations, Josh. So we'll come back during question period.
Sounds good.
Thanks so much. All right, now we'll have Odie Craig from Intelligent City join us at the front. Your choice for options.
Thanks. All right. Wow. That was super exciting. Thanks, Josh. I think that was a fantastic crash course that everyone's getting here about programming, software development, robots in industrialized manufacturing. I'm really excited to see what Porsche Consulting is doing. A bit of background, my dad worked at Porsche his entire life. I grew up in Stuttgart, so I'm a Porsche child. I grew up with lots of car thinking and manufacturing thinking. My dad was partially responsible for the new paint line they built 10 years ago. He retired since. That was really fun to see. He talked about at the end how they had this beautiful new factory space where the cars dip into the paint and then come back out. And it looks so cool. They built a meeting room next to it with a big glass front so people can see it. And no one ended up booking that meeting room because every time you had a meeting in that room, people would just watch the cars instead of actually having meetings. So it can be quite fascinating. It can be a lot more about design than you might think. So, oops. I want to talk a little bit more You've already seen so much, as Steve showed everything. The video was done during the pandemic, by the way. Let's do this way. Okay, so Intelligent City is what we call a housing technology company with a product and platform-based approach. My name is OD Oliver David. I'm the CTO of Intelligent City. I've been there since its official founding in 2018. I have a background in architecture and I have a PhD in robotics and timber construction. So I'm really excited that we have this event here at the Architecture School because if you're wondering why you're watching people talk about robots and manufacturing stuff while you are the architect of the building, you're supposed to design the building, right? What the hell are you doing with robots? Well, think about what the impact of your design has and think about what the tools that you have available to you are doing to the way buildings are designed and made. We have, in the last, I would say, 50 to 100 years, architects have become accustomed to the idea that they're responsible for the design, the look and feel of the building, but not really for how it's being done. And then afterwards, they're angry how it was executed because, you know, the builder did something that they didn't want to. But, well, where have you been when it was built, right? How much do you know about how it's actually being built? Where are the architects of all these cars that are so beautiful? Well, they're the product designers, right? And what are the product designers learning when they study product design? They learn about materials, engineering, manufacturing. They know what can be done and what cannot be done. And they work within that ecosystem of possibilities and they come up with new designs within that. They innovate with the tools, they innovate the tools, and they innovate the design. And so that's where we believe architecture and construction is going. We are moving from a one-off, bespoke, project-based industry to a product-based industry where companies will come up that are like car manufacturers, huge companies, huge output, beautiful designs based on a commonality that they have so that they can actually scale and deliver, but at the same time incredibly customizable. And so that's really the tricky point, and I have a few slides on that. It's a bit more difficult than in other industries, and that's maybe why we have this huge gap that Josh just showed in terms of productivity increase. So Intelligent City, we are developing a product platform and generally the idea of delivering whole buildings as a product. That means we are developing construction systems, building systems, with mass timber in our case, high-rise mass timber building systems. We are developing manufacturing technologies to manufacture these building parts and components to have that automation and flexibility. And we are developing software because somehow we have to control all of that. We have to control how we design the building. We have to give sort of rein in the design choices and possibilities. We have to make sure that we can build what we design, and we have to make sure that we can actually transfer that down into the manufacturing line and we can actually build those things as well. And the 3D models aren't just for show, they're actually information models for manufacturing. Bit of a different slide than what Josh had, but same message. What the hell is going on? We have a $8.8 trillion industry worldwide when it comes to construction. And operating and building buildings is responsible for 40% of global greenhouse gas emissions. And yet, well, maybe we have a 2% increase in productivity. All in all, in the last 70, 80 years, we had around 0% productivity increase, measured per capita, measured per person. So there seems to be a huge disconnect between how we build the resources we have and the technology that's available to us. And somehow technological innovation has not really revolutionized the AEC industry, the architecture, engineering, construction industry. in the same way it has almost all other industries, right? But I think, and we think in Intelligent City, there is a way to reconcile these potentials of technological innovation, industrialization, and customization. And this is kind of the message that I'm hoping here to give. 2 minutes on my own background. I was a student in architecture at the University of Stuttgart, and around 2009 is when the Institute for Computational Design and Construction was founded by Professor Achim Menges, and I kind of took a left turn from doing some cool architecture to just totally nerding out about robotics and computational design, parametric design. And it was a fascinating time because it was very early on. We had our industrial robot and we just experimented and we just looked at, what can we do with the robot? What kind of cool things can we do? It doesn't really matter what the outcome was. And I put these slides in just now because Cheryl talked about that earlier. The relationship between the tools that we have available and the way we build and design buildings is extremely important and really fascinating, especially in timber construction because it's such an old methodology. So you can really trace the relationship between the pre-industrial era where we had hand tools and really sort of were forced to custom build every building. Every part was custom made. We were forced to use our hands, and thereby we had to preserve as much energy as possible. We didn't want to cut too many times. Through the industrialization, when we started to automate the energy that went into the manufacturing process, but we couldn't really customize it anymore, so we all agreed that we would standardize stuff. That's, by the way, why the world looks like it does, is because everything is standardized, right? And it helped. It helped a lot to say everyone is making 2x4s, everyone's making 4x8 foot sheets, because then it's interchangeable, tradable, and you can make the same machines everywhere, right? So it kind of worked for a very long time. And then somehow 30 years ago or so, we started using CNC machines and equipment where we could also program the shape that comes out of it, right? So you first we gave up the energy input, and then we gave up the information input into the machines. And so at that point, we were using industrial robots, CNC machines, and it kind of freed us up to have some rigorous standardization and rather standardize the logic behind it, not the actual outcome, right? And that's kind of what parametrics is about. You standardize the underlying process rather than the artifact that comes out of it. And so for a long time, I was doing research at ICD about parametric timber systems. This was sort of the highlight of that part of my career when we designed and built a manufacturing process that would allow us to build a large shell, a discretized shell using timber. Actually, we started with the manufacturing process of that, how to manufacture these cells, and then we built a design tool around that would allow us to design shells with that system. So you design a shell, you get the model out, everything is sort of ready for manufacturing, and we build a small robot cell that can then make these little components. It's using glue and so on. Every part is different always. There is no standard. The standard is the process, right? Whether it's a 4-sided or a 7-sided polygon didn't really matter. The robots, as long as the robots can reach it, we could build it. And that was the idea, right? You leave those standardizations behind you and you focus on the process and you focus on what the machine can do, and you can still create beautiful designs, at least in my point of view. It was about showing that design possibility, right? So how come that we have such a high level of customization on the one hand, but then we have so little sort of industrialization and automation in the construction industry? And I'm actually going to take here a little bit of a comparison to the car industry. Sorry, Josh, it's not a Porsche. But I also don't want to actually talk bad about the car industry, because it is sometimes a very good example, sometimes it's not a very good example. The reason why it's a good example is when we talk about platform-based design, it's exactly what Josh talked about. We have certain parts that are variable, we have certain parts that are standardized. And that allowed the car industry and many other industries, phones, laptops, and so on, shoes, kitchens to sort of focus on the flexibility that is needed and otherwise standardized parts, right? However, a really big problem is that that kind of approach doesn't work in the construction industry. You can't go on an online car configurator and make your Porsche 2 inches wider because your garage is 2 inches wider and you want to use up the space, right? You want to occupy the space. You don't want to lose those 2 inches. Well, that doesn't work because the stamping process to make the frames of the car are fixed. They cannot change. And that's okay. We all agreed to that collectively, that this is the level of customization that we want. And we don't want that much more customization. There are enough different products out there. So if I want a bigger car, I can get a bigger car. And I don't have to change the 911's design. But that's kind of where we are in construction. Every lot is different. Every jurisdiction is different. Every client is different. And many developers, if they are your clients, want their own unique design. They want their own brand, by the way. You are not the brand. The developer is the brand. You're just designing for the developer. So we are not necessarily building cars. We're more like building planes, I would argue, because planes are B2B, right? The airline buys the plane, customizes it, and then sells it to sells the seats to the people that fly. So there's a bit of a there's not really a good analogy on what we are actually doing, right? But I hope it translates into a bit of a thinking about how we can combine this standardization and manufacturing at scale on the one hand, and this extreme level of customization that buildings need on the other hand. So this is why we have developed a product platform. What is a product platform? It combines what I just talked about: design, manufacturing, software, engineering. And the Intelligent City product platform basically consists out of a number of core elements. Our own building systems. We are making envelopes, sort of all the vertical envelopes of the building. We're making the entire structure of the building. We are integrating mechanical and electrical systems in them as well. And of course, we have processes such as our own manufacturing, our own software, and people and knowledge that form the basis of this collective platform. And then we have what's called complementary elements. This is, by the way, out of a rule book for product platforms adapted to our own system. We have complementary elements such as the kitchens, and you saw a little bit of a parallel here in Josh's presentation. Balconies, prefab bathrooms can go in, and so on. We are building interfaces, right? We have to interface. We can't do it all. We can't have like a 1,000,000 square foot factory. Some do, apparently, and build everything. So we're interfacing with external suppliers. Construction also is very local. You can't just get one sink from one supplier and spread it out all over North America. You have to be able to source sinks and toilets from different suppliers in different jurisdictions in different cities. So it has to be localized. So you have to have this flexibility in these interfaces. And so all of these components form our product platform. And out of that come different product families. So for example, a low-rise solution, a mid-rise solution, 6 stories, what do we have here? 7 to 12. That's sort of a sweet spot for mass timber because you're leaving the low-rise stick frame construction and you are cheaper than concrete because concrete really, well, concrete is at the moment very expensive anyway, but normally it would have been more cost competitive the higher you go because you're just repeating the formwork and it's cheaper to have the people on site. But when you go 7 to 12 stories, which is a really great scale for urban livability, and really sort of focus of where cities are currently trying to densify, that's where mass timber shines. So that's kind of where we positioned ourselves, but we can also build more low-rise and we can build more high-rise if that's necessary. So you have these product families, they serve different market segments, and then together with some bespoke components, you end up basically building your individual projects. So that's kind of how we are thinking. And so out of that platform, you can build a whole variety of different buildings. These are all buildings we have been designing or are designing. But it's really all down to, you know, a limited set of possibilities, and that's really important. So what I want to talk about a little bit for the second half here is what does that actually mean? What kind of technology are we developing? It's, you know, it was really fascinating for me to be in academia for very, very long, and coming out of architecture, learning about robots and how to use these tools to do cool designs. But what I also realized, of course, is, you know, there is a different approach compared to the traditional process where you normally go sort of top down. You start with a design and then you think about how you make that a reality. Happens when you do model building. You kind of have to think about how that, you know, works with foam board and acrylic glass and stuff like that. And then when I got approached by Intelligent City by the co-founder Oliver Lang, I realized that this logic of actually thinking about manufacturing first and the flexibility of manufacturing, and then building a design system around that, that's actually really applicable to industrialized construction. So learning this stuff at university was really, really helpful, and at many universities, ETH, Zurich, Stuttgart, many others, also here in North America, you know, you have a robot here, you can learn about this stuff. That really helped me figure out how we can innovate in the industry, how we can innovate, how we actually build buildings. So what we decided at Intelligent City is we need building systems, what's called EcoSys, basically our superstructure, our envelope system, and our MEP integration. We need assembly lines, robotic automated assembly lines that can build these, and we need software that can actually control that and generate information. So when we talk about product development, we look at sort of what are the markets that we want to enter, what are the buildings you want to build, how do we want people to live, and as architects or people with architecture education, that's really at the core of our company and where we really started from. Oliver Lang and Cindy Wilson, the co-founders of Intelligent City, had an architecture firm for 25 years, and they experimented with that. Actually, these are pictures from their projects. This is, by the way, this is a volumetric modular building, and I don't think you would guess that by the looks of the living room here. Modular doesn't have to be ugly, right? If you think about the design. And so we started to look at different typologies and different typical archetypes of buildings that we can sort of foresee in Vancouver, in Toronto, in Calgary, Edmonton, Ottawa. All of these locations have some specific requirements, but they have many commonalities as well. And so we have really been looking at if we can develop a building system or building systems that can ultimately supply to all of these different typologies, that we can access, this is a bit of business thinking, if you can access a big enough market segment, then you will have enough projects to support all of that technology development. But it really ties back into the building systems, because if you design your layouts for your building and you know, where are the plugs and where is the kitchen and so on, all of that integrates ultimately into the mass timber structure, and you have to know where your penetrations are, where is your grid, where are your columns. So it really goes back into the idea of adaptable but repeatable building systems. And if you look at all of the systems that are in a building, and there are more than that, the interesting thing is that there are prefab bathroom suppliers, there are prefab kitchen suppliers, there are fascinating companies out there. They make prefab partition walls, right, so you don't have to drywall on site. But there is no one who's building mass timber components. And that's why we decided we have to really look at that first of all. We have to figure out the structure of the building and the envelope of the building, because that's very important, first of all. It's very expensive, and also it's where you see the variation and where you see the design choices, especially in the envelope. So we have developed and certified these passive house certifiable envelope panels and a mass timber structure. The structure is actually consists out of floor cassettes that are double layered. So they are double layered stress skins, two-way stress skins panels. They are glued together, and they have on the inside, on the left you see the thickness a little bit. On the inside they have, oh actually you see it here on the right, they have mechanical and electrical systems inside of them. And so you kind of have like a motherboard. You kind of take those, put them on site, plug them together, and half of your electrical systems are already done. 100% of your mechanical systems are done. Ventilation, if it's localized ventilation, it's all done. And if not, you plug it into the stack of, or the vertical shaft of the building. So you can see how much has to kind of fit together when you do all of that. It's very important that oftentimes we are the architect of the building, so we can coordinate all of that. And if not, we basically do what's called design assist. We are kind of helping the architects and the construction firm figure out how this all works so that they can use our systems. And the envelope system is similar. It's mass timber based. So on the interior, you have actually a mass timber structure, and on the exterior, different types of claddings, different types of windows, depending on what your design wants to have. So we've built a few little things so far. We're kind of ramping up. Our factory is starting production in a few days or weeks on our first project, so it's a very exciting time. What we did do is we built a little mock-up. Little is relative. It's basically a cross-section of a high-rise building. You can ignore the crossed-out steel. That's because there's no other shear wall in there. So something has to stabilize that little mock-up. You wouldn't normally have that, so you would have just clean wooden walls, clean wooden ceilings, wooden columns, as much wood as you can possibly want. I'm a fan of white walls and wooden ceiling, but that's not for the mock-up. So what are we developing in terms of manufacturing technology? And that's why we are here. So we have developed several automation lines or assembly lines that assemble our floor cassettes and our envelope panels. And we also developed our own CNC centers for the parts that we make. So this goes a little bit, there's always a bit of a discussion, vertical integration versus outsourcing. When it comes to CNC machining, that's something that's actually really important to have in-house, because then you can source standard materials and you can just build up your stock, your warehouse, and you don't have to pre-order from your supply chain too early on. So this is our current factory. I should have a picture. It's a very old animation. Those are KUKA robots. We do have, let's skip over here, we do have ABB in the meantime. They have really been a great, as I said in the other video, they have been a great collaborator and support to help us build these cells, as has Brave, who are our integrators. So when we built these assembly lines, we had a lot of ideas of what we could automate and how we could automate it, and Brave really helped us make that a reality. So now we have a few robot cells, and we're working on further robot cells to automate the assembly of these mass timber components. The really fascinating thing is every mass timber piece here is 200 kilos, right? You can not lift that by hand. You would need a crane, a gantry, or anything. So we're working in a realm where humans don't work and cranes are just overkill. So you are somewhere in between, and that's exactly where those big industrial robots can work really well and help us assemble with super high precision, you know, on a 10-meter long panel. We're talking plus minus a millimeter or two to achieve that level of quality. You know, you have air tightness issues otherwise, visual quality, of course, all of that stuff. And last, we are kind of tying this all together under an umbrella of software automation. And that's also really fascinating, because similarly to manufacturing, where you're kind of entering a space that hasn't existed before, because most processes and parts that you can think of in construction were developed for two hands, right? I always like to talk about wood screws, because wood screws are extremely difficult to automate. When you put a really big screw into a piece of lumber, you have to adjust your pressure, your orientation, you have to know when to stop. A robot doesn't know that unless he gets all the sensory inputs, right? So that's very difficult to automate. So if you look at the car industry, for example, most of these processes cannot be done by hand anymore. They have been developed so far away from human labor that nowadays you could not put a car together the way robots are putting it together. So it only works with automation, and construction so far has only worked by hand. And so it's a huge gap that we are trying to fill up. A little bit similarly for software, on the one hand, what you have, when you search for parametric design or computational design, what you're probably seeing is the stuff on the left. You're seeing some fancy, super crazy one-off projects that are sometimes very beautiful and worthwhile, of course, but they were all sort of part of this very early experimentation of what software can do with architecture and how we can design really crazy things. And then on the other hand, you have the sort of one-fits-all standardization, modular construction. You saw the other picture in George's presentation, post-World War II, and there's somehow nothing in between. Well, the one on the right serves a few percent of our industry, and the one on the left serves probably less than 1% of our industry. But there's like a 90% center where we have to build housing, we have to build office spaces. How do we do that in a more automated way while still keeping design quality but accelerating a design process? So that's where kind of we see a parametric platform come in, where we have a design software that allows us to work within the constraints of the building systems that we developed, but give us the freedom of design choices and make some really nice buildings. What that does too is if you design with such a software, so what Delta Studio does is sort of the two pictures on the left. It helps you design a building within certain constraints, and then Delta Systems is the second piece of software that populates that building with all building parts. So now within a few mouse clicks, you have the entire BIM model of your building, and you also have a ton of data, of course. So that's really important for your client, because now you get to tell them, well, this building that I just designed in 5 minutes, this costs $5 million to build, and this costs 5.5 million. And this one has such an LCA and such an LCA. Here are your emissions. All of this data is available suddenly to really make informed choices. And then the software goes further, and Delta Manufacture basically is our third part of the software that takes that and turns it into a manufacturing model, gives us fabrication drawings, shop drawings, robot code information. You've seen this before. I'm not sure if it... No, it doesn't want to... Oh, this is cool too. So that's kind of what we're talking about, right? I mean, the building shapes change dramatically here for purpose of showing how the dashboard works. But you can imagine that small variations in a building design can actually sometimes suddenly have some really big implications on your life cycle assessment, construction cost, the yield of the project. So these things become extremely interesting. You kind of can do research on your own building because you have these tools available. And of course, those tools then also generate manufacturing instructions to ultimately build your building in the factory. And what's really different to typical industrialized manufacturing is that every building part that we make is different. And so there is no standard code to pull from. We make a new set of instructions every time we make a new building component. And so we need that data flow, that live data flow from the design 3D model to the manufacturing model. So as you can imagine, none of this works unless you converge these disciplines under one hood. Our company right now is 42 people. That includes shop labor as well. So we don't have actually a lot of engineers. We don't have facade engineers. We don't have mechanical, electrical engineers. We're still collaborating a lot. When you build a building, you have over a dozen consultants, right? All of these are also different, whether you're in BC or in Ontario. So you also have to have that network of people that you work with. So collaboration is extremely important. And at the same time, you also have to re-educate the industry because you're working on a product, you're not on a one-off project. And so the way this whole collaboration works really also changes. I have this slide. That's I don't know, it's 1 or 2 years ago, we were half the size. Right now, we are working really hard on making the factory actually work. So as I said, we have one project, our first real project is an 8-story building in Vancouver with BC Housing and the Vancouver First Nation Housing. that's going up sometime later this year. We are starting manufacturing now, and we have a handful of projects that are coming into our factory. So many actually, many also in Ontario, that we are looking to expand. We're working on a new factory space here in Ontario and also to expand in BC. That being said, we are hiring, and I hope I was able to inspire you a little bit to reach out of your comfort zone, as Philip said, and think about what manufacturing and design and engineering, all of that stuff has in common with what architecture is actually really about. Thanks.
Oh, okay. I hope we don't lose first year class here. I sense a migration. So we have one more presentation, and then Steve Powney's going to wind this up for us. So yeah, we're going to do a hookup here. No, it's I'd imagine do you guys have another class? Oh, you're not. Yeah, first years. I know, well, I am not in control of the school schedule. The crowd from the outside will come in now. Thanks, everyone. So the next speaker will be Cooper Lane from Brave Controls. And this idea of integration, which you're now beginning to understand, the critical point that brings together our manufacturing and our ideas. We're just going to hook up the... Okay, so Cooper, thanks so much.
So I haven't even said anything yet, so I can't technically say it's something I said, because the audience has dwindled quite a bit. I know that Greg Sullivan's also listed as a speaker here. He sat in the back. I don't know if he's going to do a Drake walk-up, or no, he's not going to speak today. Okay. So I'm going to do this solo. So I am Cooper Lane, Vice President of Sales, specifically at Brave Control Solutions. We are, as has been mentioned before, a systems integrator, and we're focused primarily on offsite construction. We started this push back in 2021, really is when we started our business development push into offsite construction. We were founded in 2008, and like a lot of automation firms in Windsor, which is where we're located, we were primarily automotive. In 2017, late 2017, I think it says 2018 there, we were approached with our first opportunity in offsite construction. When we finally commissioned those projects, there were 4 large machines, which you're going to see later in the presentation. We saw a tremendous opportunity to stick around this industry space. What we do, as a systems integrator, we actually design and build automation, so robotics and automated means of manufacturing. OD was showing some of the machines that they have there, and as he mentioned, we were their systems integrator, so we worked with them to design those machines and build them, install them, commission them, and support them as well. I do want to add, as OD was speaking, we consider them to be in the stratosphere as far as their understanding of design for manufacture. They've been a pleasure to work for. I'm going to pump his tires a little bit here. But because of that understanding, their machines we can treat more like a typical automation project where we know that we can build a machine, we know that they're going to design around it, and it's going to work. We have a lot of challenges around that, and I'll expand on that as I proceed. This is our legacy customer base, so it's where we come from. A lot of those logos I'm sure you guys are familiar with, but this is the space that we live in now. Most of the companies up there are off-site construction. We have some GC. Z Modular is where we got our first opportunity. Z Modular being a 3D volumetric modular manufacturer, and they specify steel in their product. There's some dimensional wood. As far as materials go, we work in structural steel, light gauge steel, dimensional wood, mass timber, and then a mix of components for structurally insulated panels, which is the, right now, it's specifically the Boxbolt project, which Josh mentioned, and I'll focus on a little bit in a video that I'll share. The chart, actually, I started to laugh because I think OD said 0%. I think that Josh said 2.2%. I think it depends on the span of time that you choose. I try to sell robotics, so I choose a span of time that shows a decrease in productivity. So from 45, I think, anyways, over 75 years, and until the more or less recent past, we have shown a decrease in productivity in construction. And you can see the other industries that it compares to, and that decrease is roughly 1.5%. Again, these are now down in the right-hand corner. This is my, if you follow me on LinkedIn at all, LFG is something I use quite a bit because all of these staggering facts in this industry space, why are we not modernized? I always use the analogy is that we don't need cars, but we come from the automotive space, and I know the amount of automation and the amount of focus on modernizing and getting fractions of a percent of more productivity out of these car plants, and there's very little being done in the construction space. We need houses, and it's clear we need houses. We're in a housing crisis on a global scale. So I'll talk a little bit about the lessons that we've learned in offsite construction. Like I say here, offsite construction is not automotive. And again, this talks a little bit about what Josh mentions in that we use principles and concepts from automotive, but offsite construction is an animal on its own. We're still trying to figure out how automation is going to work as efficient as we need it to in this space. The lesson that we learned on this is that there's concepts, again, that we can use from automotive, but the variation that we see in construction products, again, like what OD had mentioned, is something that presents quite a challenge for automation. And I think it was Josh that shared the picture of the prefab homes. That was a time where automation did fail and was strayed away from in offsite construction because of that. They thought that we could make automation work around a cookie cutter product, and the fact is that the consumer doesn't buy it. Doesn't matter how you make it, you can't sell it. So again, lessons that we're learning in this offsite space. So I'm focusing on offsite. Obviously, there's a lot of talk around conventional too. We focus on offsite because we feel it's the quickest path to modernizing the space and to getting productivity up to the point where it needs to be. One of the challenges that we see though too is that offsite construction is a lot like conventional construction. A lot of these companies that either are in the space or are going to the space are not implementing these processes and methodologies that we see from automotive. So it's a construction site inside four walls. We see a lot, we'll walk into a potential customer, they actually call their facility a warehouse. Well, when you manufacture, you typically call it a factory. So we're helping companies understand, what a factory looks like and how we get them to a point that, we can start to see the output, the efficiencies, the quality that you typically see in an automotive plant or any other industrialized sector. I show here too, like I talk about, what these modular factories look like. I sit on a board with the Modular Building Institute, and I get in this debate a lot with owners of modular manufacturing outfits where we feel anyways that when you're building something off-site, you should be able to say that it's cheaper, and it's not. A lot of times it's actually more expensive, which doesn't make any sense to us. The argument that I have is that if I took a layman or a layperson out to a job site, showed them what a job site looked like, and then asked them, hey, if I'm doing this in a factory, what do you think is cheaper? And the answer isn't typically, well, the answer would be that it's probably off-site, but it's not. And it's because they're not employing these methods. So again, back to lessons learned. We talked about using automotive and why automotive doesn't work. The major lesson that we learned in the space, and it's why we've conjured a lot of interest on a global scale, is this need for flexibility and automation. The lesson that we learned came in our first project. Our first project, again, like I said, was, oh, that's the wrong button. But our first project was with Z Modular. And Z Modular is manufacturing 3D volumetric using cages like what you see here. They fabricate that cage or chassis, and they fit it out. This is shows some transparency to show what the inside of that chassis looks like. but they fit it out and they build buildings like what you see here. When we were first approached by them, we were asked if we could automate the fabricating of that cell. And I'll show a video of what that machine looks like now. So we agreed to take on the project, and what we did, I show here the 3 different types of automation. Fixed is what you typically see in automotive, make the same part over and over again. Programmable is with what we actually set down that path originally to give them a piece of automation that would be programmed from more or less a library. So you'd have a library of parts, and what we did at the outset of the project was we took a building like this, we looked at the set of drawings, and we found roughly 30 different variants of these chassis in that package of drawings. So we set out to build a library to build, first of all, those 30 different modules or chassis, and have a library that's expandable to 150 different types. And the customer loved that because it was going to decrease setup time. It was going to, the productivity factor was going to be significant. So we set down that path. We immediately hit a challenge. I would say probably a quarter of the way through the design of that machine, they won another building, which looked like this. And in that other building, we found 30 new chassis types. So we immediately, on the second building that this company had won, doubled their library space. We knew that we were going to chew through the 150 slots for recipes almost, well, before the machine was actually commissioned. And what that means in automation, in conventional automation, would be the actual reteaching of robots. Taking a robot, moving it to a weld position, teaching the robot a new material pick, a new material drop. We knew that that wasn't going to work. They were going to be forever teaching robots. It wouldn't be a production cell. It would be more of a robot teaching cell. It wasn't going to work. So I'm going to now summarize months of hectic engineering to come up with a better solution, one that we knew that the customer would be more accepting of. And we came up with CAD to Fab. CAD to Fab is more the third column, flexible automation, where we can actually take a model file from BIM software like Revit. I think Revit is probably a platform that you guys are familiar with, but something that you design a building in, that you can generate a universal file format like an IGES or a step file. So you export that model file. We use aspects of that model file. So there's a software that we've created to actually create robot code or automation code to teach the automation. So you can design something in the morning that you can make in the afternoon. You could actually make it within minutes of running it through our code generator. Now, each one of these machines comes with a specific piece of CAD to Fab. So, you know, I'm talking about a chassis here. We're building SIP panels. That piece of CAD to Fab right now would be tailor-made to that product. So it's set up in advance. So it focuses now on the productization of the design as well, which is something that OD touched on. But CAD to Fab, like I said, is something that we've invented in this space that, again, has conjured quite a bit of interest on a global scale. What we realized once we created this CAD to Fab piece of software is that we now had a piece of equipment or a tool, or we could offer anyways, a tool to our end customer that would allow them to do a lot what OD talked about as well in that iterative design. So you could actually start to use that phrase DFMA. You could design around the machines that are on your floor. You're making significant investments in these pieces of machinery, multi-millions of dollars, so you want to make sure that they're running as efficiently as possible all the time. We could do that now, and again, this was a lesson that we learned in that originally what we gave our customer was something that looked like this. We actually called it a cheat sheet. Not very modernized, if I could say so myself. So what the challenge that we came up with was that we had this cheat sheet, and somebody didn't see that cheat sheet. Now I'm simplifying exactly what happened, but that cheat sheet didn't get in the right people's hands. A building was designed, material was ordered, a feasibility study was done, and we realized that a lot of that design couldn't be made as efficiently as it should be in this major investment that the customer made. So we knew then that we had to automate the process of really more or less the feasibility study. But what we're doing now is we're putting a tool in the architects or the designer's hands where they can take a chassis design, a wall design, whatever it is they're designing for the equipment that we've made, run it through this feasibility study and make it as efficient as possible, months, sometimes years in advance of it actually being made in the machine. So this is, again, this is something that comes with the machinery that we deliver. I have some examples. I think it's going to start on its own. No? So OD touched on this a little bit. I think he showed the assembly cells that we built. I know he did, but he didn't share much on the machining cell that we developed and built for IC, and we're selling now in the mass timber industry. So this cell, again, like I said, we've developed it with IC, and we're commercializing it across the mass timber industry. This machine is capable of, I think there's, OD's going to maybe correct me here. It's better when he's not in the audience. I think there's 8 tools on this robot. Anyway, circular saw, routing, milling, drilling. I think there's a chainsaw on this, correct? Yeah, well, envision a chainsaw, because that's pretty cool. And so this robot's capable, so we have a robot that loads and unloads, and then that list of tools, including a chainsaw, is something the robot can change out. So there's a rack of tools like what you see here, and it puts whatever cutting tool it has to use on the end of its arm and goes through the process of cutting the material to what it needs to be. So that is the mass timber machining cell. Do it manual. Now it's going to go through my entire YouTube. There you go. So Josh touched on Boxable. Boxable is also a customer of ours, which really, like I said, CAD to Fab was something that caught their ear. Mind you, I mean, this is their good example. There's a couple of examples of companies like them that they could be very standardized, but they do realize that at any given time, the consumer could dictate that there has to be a small change or a significant change really to the product that they're offering. So having flexibility in their assembly lines is critical. So right now, what we're building is the machine that you see. The simulation is going to start there. It's a variation of this machine. Steve from ABB sitting here saying, well, I don't remember selling you these robots. Don't worry, Steve, they're not there yet. But so this variation of this machine is a little bit more simplified than what you see here, but it's the actual manufacturing of the wall panel that they use to build the, I don't know if you guys have seen the Boxable unit. I know Josh shared a picture of it, but it's a fold-up house. So it's an accessory dwelling unit. It is a permanent structure. Right now it's currently 20 foot by 20 foot. They will be offering a 20 by 30 and a 20 by 40 and eventually have them stacked together. They want to get to a point where helping them, again, Josh touched on it, but get to a factory that's more like a car plant where we could produce, they call these a casita every 5 minutes, at the very least, actually. I think their ambitions are a little bit faster than that, but we know that we can get to 5 minutes. So what we're doing here is building that universal wall panel, and every wall that you see here could be made out of the sandwich, really, that's being made on the video that's running. The windows, the doors, all of those aspects are added in the machining cell at the end of so it goes through a lamination process. And then it's going to now index into the press operation as well as the machine. You can see them in the next screen as it shoots over. So there's 2 presses and 2 CNC machines. The press is going to help it cure. And then in the machines, it's going to put your windows, your doors, your electrical, your socket locations, or if it's the roof, it's going to rip them into 3 pieces for foldability. I'll show you real quick what that looks like, the fold-up aspect of the house. But it ships like what you see there and folds out. Like Josh said, it's record time for sure. I mean, no other ADU is going to be set up this fast. And if we get to a point that they're actually hitting these production times, we're now starting to address multi-million door crisis that we have in North America. And really, there's global interest in this, obviously, as well. So that's Boxwell. And now this is our first opportunity that, again, like I said, we delivered 4 of these machines. And this is where CAD to Fab was born. What you're seeing here is all driven from a CAD file. So an step file, like I described, is created from a software platform, and it's used to create the code to, first of all, in this fixture is actually setting up our work hold fixture. So it's putting in, it skipped across. I started at a different point, but you can see on these, the orange rails, your floor joists are already set up. Your robot has put those floor joist tooling anyways into place. They can move them around, put them back on the rack. It's putting sideband tooling in, I believe, at this point, or no, vector blocks. Yeah, so the vector block is this stacking technology that ZMod uses, so they could go up to, I think they're up to about 14 stories now on this construction. There's a little bit of manual intervention here. So this is the kind of stuff that we do when we're delivering machines like this, and we're actually costing it out. So in earlier stages of a machine like this is that the automation to put these sidebands in didn't show the cost benefits. So we drop them in with crane, and then the robots get back to work. They're putting in floor joists. They'll put in all the floor joists, and I'll skip ahead because it takes a little bit to explain, but we then utilize what we're doing with CAD to Fab essentially is teaching robots the as-drawn state. So we need some sort of technology to recalibrate them for as-built, because this steel is never going to be in the exact same location as it's drawn. So once it's dropped into the machine, we utilize, ABB has a technology called SmartTac. There's vision and laser technology that can help the robots do this, but really essentially what it's doing is it's helping the robots find their place. So CAD to Fab, we always say, gets them in the neighborhood. CAD to Fab gets in the neighborhood, and then we use these touch or vision technologies to help the robots get the key in the keyhole. So they're actually touching the steel to recalibrate to the as-built state, and then they go along and they weld the chassis, which is a finished chassis, is something like what you see here. I'll just skip ahead so you can see what that finished chassis looks like. And then the next slide, I wanted to show what kind of variations we can actually integrate into this machine. So what you just saw there is roughly a 32-foot long chassis that was being built. Sizes in this fixture can range from 60-foot long down to about 10-foot long, 8-foot wide to 16-foot wide. And again, now to go back to what's been talked about in several presentations before this, is what we've done here is we've given the architects, the designers, the ability to, we've given them a window to design within along with some constraints, and then they can play with whatever variables they want. We can make it in this flexible automation. I was talking a little bit about this in at the luncheon, but again, the CAD to Fab and our ability to deliver flexible automation has brought some interest as well from the Middle East. So I don't know if you guys have seen, because it's on social media quite a bit, but Neom, The Line, Oxagon, Trojena. So these are giga projects that are happening in Saudi Arabia right now. The volume of, you talk about housing crisis, what we have here, we need 1.5 million more houses to, I think, in Canada. In Saudi Arabia, they need to produce roughly 40,000 modules per day, or sorry, that's ridiculous, 40,000 modules per year to get these projects done, the giga projects that I just mentioned. So the Line is something that I'm sure you've seen if you're on Instagram at all. Oxagon is the manufacturing area that would actually be built first, so they could build the line, and then Trojena would be at the end of it all. It's the actual tourist area that is just outside the line. I think one of their advertisements is actually people uphill skiing, so that'd be interesting. So they're defying gravity there as well. So what the purpose of showing this is that the opportunities in Saudi are pretty cool to us in that we're actually going to be able to, we talk about building houses like cars. Saudi is very inspired to do this. They want to bring in areas like what you see here. These are just some examples of the giga projects that are happening there as they continue to evolve as a country. They want to attract more tourism. These types of things are bringing on a lot of hospitality builds. They're building a lot around a lot of their religious attractions, so like Medina, they're building a lot of hotels around that as well. The fact or the point here is that they are very motivated to build a lot very fast. And they're developing a lot of technologies around how to get that done, which is something that we can then come back and utilize in well, customers that we have now and new customers that might be coming. I can say for sure, you know, there's a question around whether NEOM is real. I've been there a couple of times. It's very real, and every time I go there, there's something new. Last time was a new international airport. So typically when there's new international airports, things are getting pretty real. So like I said, 2021 is when we started our business development push in offsite construction. It started with that 3D chassis cell, and then we moved into we're in the building component side of things, so roof trusses, walls, floor panels, mass timber, obviously, with the work that we're doing for Intelligent City. This is actually kind of a different industry altogether, but transmission poles, so power transmission poles. We're building automated fab cells for large power transmission poles, SIP panel assembly, which is something that we're doing for Boxable and other companies. MEP, material prep and storage, so the mechanical, electrical, plumbing, actually a lot around the plumbing side of things. Reducing waste. I don't know if I touched on it, I know it was in the slide, but waste in this industry is astronomical. I attended a seminar where a representative of DPR was speaking, and they build a lot of, DPR is a multi-billion-dollar, I think they're the second or third largest GC in the US. Anyways, top 10, let's call it. They build a lot of hotels, and he had a slide, again, I guess I just did what he accused the people in the audience of doing. He's like, you guys aren't understanding how bad the scrap rate is. I wasn't, not you guys. This 30% scrap rate. So what he did was he had a table that he set up 3 Lego buildings. And these Lego buildings, like he said, they represent, let's call it $20 million in material per building. He said he swiped one off the table. He says that's 30%. 30% of our materials go in the scrap bin. And that's still happening even in offsite construction. Where if you start to integrate something like, and this is why I brought it up, we're working with a prefab plumbing manufacturer right now where, you know, they would take a copper length, cut what they want off of it, throw it in the garbage. They start to realize how much that's costing. So if you start to bring in, again, this is now capturing data, you start to realize what you're throwing in the garbage. You then start to track your offcuts. You start to track opportunities for saving on those scrap. We could bring scrap rates down to, in the industries that we come from, under 5%. Those kinds of improvements will lead to more and more utilization of offsite construction and a better environment, more importantly. So that is it. I took a lot of the sales stuff out. I do apologize if you want to buy a robot now. You can talk to Steve. Anyways, thanks for having me, first of all, and then thanks for sticking around, those that did.
Thanks so much, Cooper. All right, I'm going to let Steve Powney wind it up with the presentation here. Since he actually is the reason we gathered all together, it's perfect that he gets to finish up here. Good.
Okay, so anyway, thank you everyone for staying with us here. So what I'd like to do now is just basically try and pull everything together that we've learned today. So this is really our ABB's vision in construction pulling together, as I said, a lot of our partners and the information that you've seen today. So, that's me. What do we see in this market and in the trends within this market and the ecosystem within the construction industry? First of all, everyone showed this slide. Everyone's got a little bit different figures, but the reality is that this construction industry is massive. It's the biggest industry in the world, and it really depends where you say this industry starts and ends. So you could say that the construction industry starts as a tree. It could be that the automation that puts in the lumber mills is the start of the construction process, and it could end up, as we're talking about, places like Intelligent City that are putting together buildings. And somewhere in the middle of all that, it's that big, there's an enormous industry, an enormous opportunity, and it has to change. That's the reality of things. So what ABB did a few years ago, which was really key to our vision, we conducted a survey across the globe, many different countries, and we asked, is there a need for automation and is there a need for robotics in construction? And these are the key figures that came across. So, inside, what do you believe the main challenges within the construction industry? 44% in recruiting staff, 42% worker safety, 39% quality and consistency, and as Cooper said, 38, big problem with waste. So there's an enormous opportunity there for the construction industry. And 81% of those surveyed said that they were planning in some way to introduce automation, particularly robotics, into their production and into their business model. The number one thing that they all agreed with also was that sustainability is an enormous and their biggest item of responsibility. Also, 45% said that robots could help reduce project times. And the biggest thing that we saw, and our biggest opportunity, and the thing that stops us building houses that's needed, 91% of people agreed and have got the confidence that there will be a skilled labor shortage over the next 5 to 10 years. So the reality, when we look at figures like that, ABB thinks to themselves, well, this is a market that we could help with, that we could create, and we can actually make a difference in moving forwards. Now, these are the things that we have to do within that market. There's mega trends within the construction market, which are very, very clear and very well known. Urbanization, a lot of movement towards cities. Labor shortages, we've mentioned, individualization and decarbonisation. So that's the challenge that we've got as an industry and a global opportunity. And what ABB and our partners have to do, we have to do these 4 things. We have to add productivity into the mix. We have to add quality into the mix. You've heard these things being said over the last few hours. And the challenge, and the biggest challenge we see, is things that we've been talking about as well. We need to be able to build flexibility into the manufacturing processes. And something that really may not have come out as yet, the automation and the manufacturing processes have to be simplified. If we're going to put very high-end automation, very difficult automation to manage, difficult automation to introduce, people are going to walk away from it. So our challenge is to introduce a simplicity into our automation and our manufacturing, which make people want to use it, and they will adopt it in a more readily fashion. The ecosystem, this is why we're here today. There's ABB recognize that within this challenge in the construction industry, we're just a portion of it. As we heard, collaboration, collaboration, collaboration. In industry segments which are trying to adopt new practices, new ways forwards, particularly with automation, we have to have a collaborative approach. And we know that we have to collaborate and have partners at universities like Carleton. They're within our ecosystem that we need to adopt. We have to have partnerships and knowledge with architects and designers, which is why you're here today. That's a really key situation. We have to help people in the raw material supply make the materials which can be then automated. So we have to adopt practices and have partners in raw material suppliers. General contractors, it goes without saying, we have to be in there with these people. People, software companies, like we've heard today. Software is a critical portion of this equation. And then machine manufacturers like Brave that can pull all that together and create a solution so it can be adopted. So the ecosystem is why we're here today. You're part of the ecosystem, and you're part within this journey. Without it, we're going to fail. So we have to bring knowledge and tell you exactly what is needed in order for this industry to move forwards. These are the people that we work with: house builders, construction companies, construction general contractors, prefab module makers, rebar makers, and startup, particularly with a construction focus and particularly in software. Our go-to-market strategy is that ABB Robotics produce and deliver robotics and function packages. That means robots with things on them which enable them to work in an environment and produce things like welding, gluing, screwing, things of that nature. We've also decided, and we're very active, and another reason why we're here, we need to give advice on possible solutions within the industry to construction companies. And in order to do that, we need a collaborative team around us to show the construction industry we mean business, we know what we're talking about, and we've got people and partners around us that can make this happen. And then with our partners and system integrators, we can help deliver turnkey solutions which will enable the industry to move forwards. Targeted applications. So a lot of people think, well, what are we going to do in this industry? This is an enormous industry. Where are the targets? What are the things we need to do? And the ABB see 3 pillars of focus within the construction industry. And they're very different. A lot of you heard today was about pillar 1, off-site manufacturing. This we see as the key way forward for the industry. And this is produce metal frames and modules, wooden frames and modules, materials manufacturing, rebar assembly, and internal operations. And internal operations is some of the things that Cooper showed you, where you're putting insulation and things of that nature. The second pillar is 3D printing. There's a lot of 3D printing going on, and we're actively involved in that. In 3D printing off-site, we're looking on-site, and on mobile platforms. There's a lot of 3D printing happening now. And the third pillar, which is something we're keeping a good eye on, albeit there has been activity, is on-site robot application. These are robots in and on the construction site itself. Examples in pillar 1, you've seen a couple of these pictures. This is metal frames and modules and wooden frames and modules. A lot of different ways this was being done, but these are 2 examples. And we're actively and been successful in this. And in a 5-year journey, we're in the middle of that journey. We're in year 2, year 3, where we're actually now scaling these processes up and scaling these capabilities up to meet very large market demand. Year 2 to 4, and this has started as well, material manufacturing, wood mills, things like that, and also rebar assembly, and this has started now as well. And then we will have to move into, as we move forwards, the operations after these larger frames are built and into the internal operations. And there's development work now, which you saw at a number of companies where they're looking at developing these internal operations for the construction of the buildings. 3D printing, pillar 2. These sort of concrete off-site, a lot of activity, 3D printing bridges, all sorts of components off-site. A lot of activity all around the world, in Europe, Asia, Middle East, Japan, Canada's somewhat leading in this as well in the USA. So this is going on everywhere around the globe. 3D printing on-site, mobile platforms with robots on, which can be taken to the construction site and utilized in constructing 3D houses, cottages. A number of them have already done in British Columbia, Canada as well as leading the way with that. And then, as I say, mobile, which is part of that offering. These are some examples of applications on-site. These are all the sorts of things like painting, inspection, stone cutting, drywall, excavation, roadworks, drilling, cutting, and demolition. These things are actually happening, but on a little bit less scale, and we see them a little bit further out. They're not fully developed, or as developed as the sort of things we're doing off-site, but they're certainly things that we need to keep a good eye on in the future. Now, where can these things take us? Firstly, in an off-site factory for modular structures, there are really three ways for automation. There's fully automated, potentially, processes, semi-automated processes that will need manual introduction or intervention, and off-site and assisted. So inside this factory, there's an area which we see the best opportunities. And these opportunities are very, very clear in that there's a number of structured processes, such as the ones we spoke about with the wood frames, the metal frames, the drywall, etc., moving all the way down into unstructured, where what we see at the end of the journey, or towards the end of the journey, just like with a car factory, there will be automated cribs, automated warehouses, which will bring the components out of warehouses to the production line. So this journey will go through from a structured automation all the way through to automation out and bringing components out of the warehouses. This is what ABB have to offer, and you'll see a couple of grey spots there, which is intentional. So ABB offer a lot of different products, 140 different types of robot positioners, motors, all sorts of different slides, axis control, and they're standard products that we've been developing over the last 50 years, and they're well used in industries, many different industries. We also offer, on top of these robots, function packages for welding, cutting, spindles, which are used at Intelligent City with a Brave, for gluing, for vision, flexible locators. So there's a lot of different function packages that go onto the robots that enable them to do their job in the factory. Now, the top two are the key areas. What we see here and where we are at the moment, we've jumped over the standard cells, and now we're in a position where we're developing engineered cells with our partners inside the industry. From those engineering cells, which we help our solution partners produce, there will be a need and there will be a move into standard cells from the knowledge that we gain when these engineered cells are manufactured. And at that point, which is getting closer and closer, then we believe the industry will have a very good platform to move forwards and scale itself into the future. Why do we think this is going to happen? Well, as a lot of people have said, automotive has been really taking shape and has started to adopt automation and robotics from the 70s. We've been in this for 50-odd years. And I've been in it personally for 45 years. So I've seen the automotive industry. We know how it's worked, and it's been very highly automated. We then moved into the general industry, which is in the 80s and the 90s, where a lot of things from the automotive industry were moved into that industry. And this includes Caterpillar, John Deere, lots of different industry, and a lot of learning practices from there. We believe now the time has come with the software that's being developed, the need for the industry to move forwards, the way and the challenges that are being adopted and focused on, like yourself today. We now believe that it's time to move this knowledge with our partners into the construction industry to help enable it to move into the future. Now, so that was the vision that ABB have got. You've heard from our partners and our colleagues here how they're going to help with this and how we intend to help them. So we hope this has been of great interest to you, and we look forward to any responses soon. Okay, thank you.
Okay, thanks everyone. If I could, Steve and is Johan, there he is. Steve and Johan, I'm going to pass you Mike if you wanted to just ask a few questions. And if there's questions from the audience, I have a mic as well that I can pass over to you. Maybe I'll bring you a chair up front here, the two of you. Yeah. That's it. If we can throw darts at you.
Well, thanks for a great afternoon. First of all, it's actually kind of a small world because a couple of weeks ago I met Cooper at an event. We talked about robots. And last week I was talking to one of our research partners, and Intelligent Cities came up, so I was just sort of combing through their website. This has been exciting because we've been involved with robots for about 6 or 7 years now. And when we first got involved, I just thought you went to the robot shop and you bought a robot for whatever application you needed. And then I discovered that there's a group called integrators. We didn't have very good luck with our integrators. And, but what was exciting about today is that there really seems to be a push in the construction industry toward robotics. And again, as we discussed last week, why is now the right time for automation? Housing crisis, labor shortage. So we need more houses. We don't have people to build them. And on top of that, we have to build them more efficiently because of the climate crisis. So it's a time of crisis. So now is the time. So again, this is exciting. Again, I really congratulate ABB for taking such a leadership role in this. Thanks very much. That was my introductory comment. I'm just going to look at my questions.
Okay. Well, so I think then I get the enviable task of having the first question. But my question is, especially for those that are working in the educational space, let's say our school as well has been thinking very carefully about what the future of an architectural education is going to be. And so I'd love to understand, as construction processes are changing, as the tools that we are going to use and consider for building are changing, just as a speculation, how might you see that both undergraduate and graduate education would have to evolve as well? We all have a technology sequence in schools of architecture. Are those technology sequences still adequate for teaching the knowledge and the skills that might be, present very, very soon? It would be a real shame to think that we are giving our students an antiquated curriculum. And so, my first question to those that have gone through schools of architecture, that are maybe recent graduates of schools of architecture, what do you see that needs to change, or what might we need to consider in the next 5 years to ensure that our students moving through are able to participate in what is going to be, as you mentioned, and actually many of you mentioned, a very, very fast-growing, economic and construction space?
Okay. Is it on?
Test. Hello?
Yeah.
Okay. I was very lucky to start architecture school when we still had to draw by hand. It was right after the first year when they changed that. So I was still part of that discussion where half of the professors were screaming that how dare you start right away in Vectorworks. That was what we were using in Germany a lot. And not teach students how to draw properly. I still drew 1 to 20 bricks on a drawing board. So I think what's really important is to teach that these are tools. You don't have to teach the tools very much. I think it's not the job of an architecture school to teach Rhino and then Revit, but you have to teach how to approach these tools, and you have to teach that these are tools and there are many out there, and depending on which one you're using, your design will change. I mean, it was incredibly evident. My school started teaching Rhino a little bit later. I was already in past the undergrad program, and there was always this really big second year project that every undergrad went through in a group of 5, and they designed some big building, and they built huge models, and because it was 5 students in one group, it was really awesome to see that. And the moment they started teaching Rhino, all of these buildings became spherical, bubble-shaped buildings, right? And it was just so evident to see what happened. I don't know if the students noticed at that point. And then afterwards, they switched it back to some other program, and everything became rectangular again. So it's really the robot and the laser cutter and the saw and all of these things are tools to me, and we have to teach that they exist, and we have to teach that they influence the design and the construction process. We have to teach about materials as much, and all of these things are becoming sort of a library of things that students can have access to and that you have access to as an architect later on. You do not have to teach how to become a software developer. You do not have to teach how to become a roboticist, because that's a different program, right? But it's more of a generalist that the architect becomes, more of a master builder, I would say, knowing how to use these tools. Because oftentimes, and this has been said, I think 15 years ago, the architect normally either underestimates what's possible and is very conservative in the design, or they overestimate what's possible and they just go completely crazy. And there's no real scale, right? They don't have experience of what's possible. I think that's really important for architecture education, so that we get architects that are very well skilled in the entire process of from design to building a building.
I'm going to ask a related 2 questions, actually. One to Philippe and one to Josh. And this also has to do with pedagogy. And so to Philippe, can you tell us more about the role of apprentices at ETH? You mentioned there are 200 apprentices. What is their role?
That's a very good question. I think at the moment they are not in our new field of digital construction. They are not well integrated at the moment. So, but in Switzerland we have a different education training. So 80% from the peoples or from the students after middle school, they join the workforce and they start as apprenticeships. So I did in my past. And then I met in the workforce people who teach me how to use robots in the end, and I could learn from their knowledge, and I wrote a lot of instruction manuals for ABB too. And so what I try to say is we have to work on this, because in the future we need more specialists who are able to share. I seen in my lab in Switzerland that the architects can play a very important role in this game, because architecture can very good interact with different disciplines, and they can drive to develop processes, and this is what happened in our lab. But at the moment we missed apprenticeships for digital architecture, but this maybe in 20 years, I don't know, I would love it if we would have more.
Something to investigate on our side, how to bring those two things together. And for Josh, the question I have for you is, you mentioned that construction has to shift from a paradigm of project to a paradigm of product. And again, coming back to pedagogy, definitely here at Carleton, we teach project, you know. So how do you envision that happening, that transformation? I hope I'm not putting you on the spot here, but just speculate.
Absolutely. So I think one of the images shared earlier of, I'll call it the 2 extremes of, cookie cutter, mass-produced housing on one side and highly customized on the other, and in the middle there being a very large space for the type of productized construction. Really what we see is probably the midterm is standard elements that can then be used for very custom projects. And we're seeing a lot of that already in spaces like data centers, where we see some of these very, very large programs covering 20 data center builds a year, where each of them is still a very unique project, but there's a lot of common elements that we've now set up industrialized supply chains and factories to build. So building things like conveyances at scale that can serve across 20 different sites, where we're able to simplify the activities on the site and take schedule out of those programs and take some of the upfront design efforts out of those programs by using common modules, but still having those sites be very tailored to the unique, building site itself, unique needs, the unique capacity, and even frankly allowing some unique identity for each of those. We do see the same in the residential space and the hospitality space. So with, again, I'll point to Admars as a company that we work closely with, where they always look towards what are the different elements that they can standardize to deliver a project, but still approach the project with architects approaching it in a, I'll say, project basis, but leveraging productized element that they're able to produce more efficiently. So it's a very consulting answer, but I'll say it depends. I think that the value is really in the nuance of what is it that you can standardize to bring process and design together to deliver a project, but approach it with some of those, potential constraints of getting efficiency from those productized modules.
I can add. I think if you draw a parallel to product design and or any kind of design school, they learn a lot about DFMA, design for manufacturing assembly, right? They learn a lot about whatever product they will design has to be repeatable. It has to be manufacturable. It has to there's no use to design a coffee machine if it costs $200 to make it. So I think that is a bit of a sense we can instill in students instead of elevating the uniqueness and the one-off. And for sure, there is a market for that, and I don't want to take that away from architecture, but there is another option, right? Instead of teaching every student to become the next architect, we should teach students that there is a huge market for building beautiful buildings that are repeatable. If you figure that out, you're going to build 1,000 times more buildings than Rem Koolhaas did, because you have access to such a big market. So I think that it can be attractive to think about that. It can be attractive not to design the forgive me, George, Lamborghini. I mean, it's all the same company now. A Lamborghini, but if you design a really beautiful Golf, that is the mass market. People love that car. That is as much value, and I would argue even more value than that designer who has done that. I would think deserves more respect than someone who has designed a $2 million car that sells 10 a year.
Again, back to automotive, but you look at, go to the Detroit Auto Show and the concept cars that are there. Whoever designed that concept car is not the guy that knows DFMA. So that concept eventually ends up with the product, the manufacturers, specialist designers. So they take that clay. So let's go a step even further in the design process to the guy who shapes his car out of clay. He has no idea how that car is going to be made. There's a bunch of engineers down the road that are going to make that car more manufacturable, right, down the road. But I think there's a level that's missing currently. I had this discussion a couple weeks ago where maybe we still have those super creative architects that still have that freedom to design whatever they want, but it's like, okay, that's cool, but now we're going to make it so we can actually make it cost effectively.
Overestimated the car industry. They also have the designers that don't know how to build.
Yes, they do. Yeah.
I want to come back to the theme of collaboration, because within a school, particularly a school with as many kind of open spaces and connectivity that we are, able to work in, this idea that students talk to each other and they collaborate, they work on projects together. When the space of a computer is kind of it's an isolating space. At the same time, it is a potential space of collaboration. And just because I have here, you know, research centers and industry partners in the same space, to me, open source software is kind of the best way for us to solve big problems about climate change, affordability, access, and to just move the industry ahead really quickly. I guess you don't make a lot of money on open source software, so as an academic, I can say that I still think that's really valuable, though, to jumpstart things. I just wondered if people had positions about, you know, this collaborative open source kind of world and how we can get over the hump of it being not a moneymaker.
Actually, we've recently been working with a group who has found a way to make money, actually. One, they developed a series of libraries, the IFCJS team. And what they do, they teach. They offer seminars, which cost, it's quite a modest cost, actually. But then what they do is they develop custom platforms based on the open source tools for specific customers. And it's actually a model that seems to be working. I don't know if anybody else wanted to.
As an integrator, and really, so I talk about CAD to Fab. So our software, the software side of it, CAD to Fab, I'm probably guilty of exactly what you're saying. It's like what I always say to our customers, you get this machine and everything's open source except for CAD to Fab, because CAD to Fab is our proprietary technology, and it actually takes a lot to customize it to your product. And giving you access to it might actually lead to some issues with your machine. Every other aspect of that machine, and actually this is something that we're accelerating at. We found this niche in the market where there are off-the-shelf solutions that are available to offsite construction. People can go out, they can buy a machine for a couple $1 million, and it does one thing over and over again. Or it does a host of things, and if you want it to do more, you have to call that company to come in and work on that machine. And they'll be there in 6 months, maybe. Or they'll answer your call in 6 months, and they'll be there 6 months after that. That, again, to go back to the car industry, is completely foreign to us and totally unacceptable. If we sold a machine to Ford that has hordes and hordes of engineers that are there to make those machines work better every day, so the day one of production, their engineers get it, and their engineers start to make it do more, do better, get that, like I said, the fraction of the percent more productivity out of it, because it's open source. So we're actually taking a lot of these machines that come off the shelf now, ripping the controls out of them and making them more like an automotive style machine, where it's like, here, this is your machine, which is then fostering these off-site construction companies to bring in more experts in controls and robotics because of the return that they get on making their operation run that much more efficiently. So yeah, I mean, there's something there for sure. Just don't touch CAD to Fab.
I would also like to add something here, because I was also really scared about open source tool at the beginning. I thought, okay, that's a big rolling stone when you start. Everybody has access to your tools, and but I realized in a research place, you want to have not black boxes in softwares. So you reach always a point where you have to develop something new, and then it's really necessary that you have access to this. And with open source tool, you can just simply add a little new tool to the big toolbox, and then this little tool is, maybe this is in your decision in the end, if you outsource this to the whole community or if you keep it as a secret for you. So I see a chance for both having a non-commercial part who is general, shared, but having also a commercial part with all the teachings and the explanations of how you use those tools. So and with the fact that we leak workforces in the future, so we have to be more efficient. So we cannot bring in too much people to those industries who can learn this, because we don't have these people. So we have to share efficient tools together.
maybe make one addition as well of perspective from both automotive as well as some of the construction environments that we're working within today. While automotive certainly falls short of open source in many, many aspects, there are emerging kind of shared platforms that we're working with both other OEMs and suppliers like Catena X to do open both design management as well as all of the supply chain transaction management in a standardized and open way that we're looking to release across global automotive and then the industries beyond that. Still in the early innings of this, but we're seeing some of that develop in parallel also with some very large construction management companies that have seen for sure over the last couple years challenges in just material shortages. So they've created these kind of supply chain platforms and starting to grow larger and larger consortiums to manage direct buying of some materials and being able to integrate suppliers to get transparency of things like inventory availability and manage materials to job sites in a more effective way. And kind of say all of this to say, you know, kind of gone are the days of a lot of industries really working within their tower or within their four walls. We're seeing across almost every market and industry that we touch, increased integration between different players is kind of highlighted today, even with Porsche, Brave, and ABB working together to help solve customer problems. I think now there's a bit of an increased openness in all companies working together with universities, with other companies, even with competitors in this space. And seeing that with, as an example, Turner Construction, large construction management company in the US, and with Volkswagen Group.
Can you hear me? Yeah, so you know, I agree absolutely with what's being said here. Now, ABB are a technology company. We supply robots, we supply technology, and inside that technology there is software which is not open source, obviously. And we, inside the construction industry, let's be frank about this, this is the largest industry in the world, with the least automation, with the biggest opportunity. So to think that you can control it all with something that you own is a little bit naive. What we have to do is really understand what we're good at, what we can contribute, and then from our value add within that contribution will become our domain and our expertise, and we'll move forwards. So everyone has to really understand this market. They have to understand where they can play, who they can collaborate with to enable it to get bigger and better, because it's going to exponentially change in the next 5 years. And we have to accept our position and move into and add value into it to enable ourselves to grow as well. So that's the journey, and that's the opportunity, and also it's the thing that we have to learn within ourselves for this industry to move forward.
So I hope that you don't feel too bad that I'm going to put the two of you on the spot for just a moment. But I think that there's something really important, and I think it's wonderful that you're here today, because you represent, to some degree, the education that almost everyone in this school is going to receive. You know? And yet you haven't had a summer of kind of exponential growth, learning something that many people might be very, very interested in. And I think Odie made a comment about the approach, which I thought was a very interesting kind of term to use and kind of framework for understanding. So I'm just kind of curious as to maybe how, as Carleton graduates, as Carleton students, your thinking has slightly shifted this summer. And so, like, what are now the things that you are thinking about? Has maybe how you approach a design question or problem changed a little bit? Do you see it in a different language? You know, what is now going on in that kind of black box of a mind of yours now that you've been introduced to working with robots?
I think, as Odie said, robotics or robots are just like another tool that we have. So similar to how we've learned how to use a CNC machine or a laser cutter, now we have another thing in our mind about how a building can be built, or components of a building can be built. And I think that's sort of the change I had here, was just another addition, not so much of a change, but another way of thinking about how I can design something that maybe, or I'm a bit more connected with how it can be fabricated now, rather than just designing something and hoping for the best, right? Designing something and having just a slight idea of what making that might look like.
For me, I could say that I've always looked at architecture a bit more traditionally. So having gone through this experience and having been opened up to the possibilities of automation and its potential in the future, it really kind of changed my perspective a little bit about how I would like to create my projects from now on. So for instance, now in Masters, as soon as professors started talking about, hey, let's do this, my thought process was, it'd be interesting to do it this way to make it possible for robots and automation to produce such a product or a house or a building, right? So it really kind of shaped my perspective of what is possible and which way we should be guiding ourselves towards.
One more thing I want to add. Does this one work? One more thing I want to add is what Philippe brought up a few times over the summer. Not really my change in my attitude towards designing a building, but in construction in general, was the idea of automation versus innovation. And what Philippe, I think, said really well was, first we need to automate, so doing basically what we're doing now, but automated with robots, with new technologies. And from that, we make room to innovate. So now we have time to maybe we don't make the traditional stick frame building with robots anymore. It's a new type of wall assembly that's potentially done in the research environment and then brought into industry. So having this, now I sort of understand what the next steps would maybe look like in academia with making space to make a change, I think.
That's a great ending. Thank you, everybody who's been here all day. To our guests that have been here from over a year ago, Steve, getting this idea that we could bring some robots for instruction into the school. Thank you so much for Philippe for his summer of expertise and really mentorship for the students, and for Christine, who's hiding up there, who did the robot courses with us from Sims as well, and Casey somewhere, and Priyam also, so other students as well. Thank you so much, all of you. So Odie, it's been really great to meet you, and really super great presentation. Yeah, and Greg and Cooper, thank you so much as well. So thanks, everybody, and thanks for the students that are still here. And I hope this has given you some new ideas to think about in architecture. Okay, thanks, everyone. Bye. And thank you, two guys, too.